friends, welcome to Coding Garden with CJ. Welcome to Code Katas, episode 40. Episode 40. Welcome to everyone. There's the CJ trolled emote in the chat. If you're new to the show, you can visit github.com/codinggarden/code-katas. All of the katas I've solved in the past are here, and all the ones I solved tonight will be here as well. As you can see in the title, I do plan to do either a 1 or a 2Q. Which is very hard. So if you go to codewars.com, this is where all of the challenges come from. And the challenges range from 8Q, which is the easiest, all the way up to 1Q, which is the hardest. And today we're either going to do a 2 or a 1. We'll decide. If you have suggestions for katas, you can submit them here as an issue. And there are a couple of suggestions for 2Qs and 1Qs that we'll look at. But if you have suggestions for 1Qs or 2Qs tonight, throw them in the chat now and we will consider them because we're going to vote on whichever one I'm going to solve. So let's say hello to everyone in the chat. And the LED command has to be 8 digits. That's why that didn't work. I was curious, but 8 digits. And hello, Cheddar. Welcome. Hello, Dino Dale. Welcome. Hello, Ben. Hello, Alka. Hello, Sean. What's up? Hello, Karan. And hello, Clink, who says, have a great stream. Hope you have a great stream. Me too. Thank you. Thank you, Clink50. 1Q. Oh my. Hello, Kevin. Hey, Daniel Garden. What's up? Hello, the other Kevin. What's up, Majestic Eye? This is just a great emote combo, right? Was it? Let me count them. Maybe it just took a second before it showed up. 1, 2, 3, 4, 5. Oh, yeah, that was right. Interesting. I wonder why it didn't work. I don't know. And hello, Alka. Hello, Karan. Welcome. Yeah, I need to get the other emotes working in my chat overlay. I haven't done that yet. Someone remind me, because I'll do that after the kata. What's up, Doc? that's everyone's favorite emote now, right? And hello, ATD. I think that's what it is. Yeah. So you have to. You can only do it every 30 seconds or something like that. I think that's what it is. And hello, ATD. 2Q. What's up, Derek? Welcome. Hello, Merchan. It's been a while. Welcome. Larry NY is asking, what's the difference between Code Wars and other sites? Code Wars is user-submitted problems. Pretty much every problem on the site was submitted by a user. There are also users can comment and rank on the problems, which I like. And you can see solutions for other people that have solved the problem as well. So I don't know if other sites do that, but it's one of the things I like about it. And all of the problems aren't, they're not all super computer science-y or like purely algorithms. A lot of them are just like fun puzzles to solve. And especially like the easier ones are really good for just getting familiar with a language. So if you're new to JavaScript, doing these like 8Qs and 7Qs, you'll become more familiar with like some of the built-in methods, especially like seeing other people's solutions. So I think those are the biggest differences, but I don't really use any other websites. But I'll show you, like if we look at some of the ones that I've solved in the past, like this super simple sum arrays. And if I go, well, actually, no, the hello world one was fun because people get really creative. But if you go to discuss, if you've solved the problem, I believe you can show solutions for that kata. So you can see the ways that many different people have solved it. The site's being a little bit slow. Here we go. But yeah, here's just a bunch of different solutions that other people have submitted. You can comment on them. So there's that. And yeah, I don't know. But I like it because they're very approachable problems, especially for new programmers. And there's some really hard ones. And tonight, we're going to try to do a really hard one. But welcome to the show, Larry and Y. Welcome. Hello, Client Telephone. Hello, Carnalite. Welcome. Hello, ATD. Hello, My Coding Journey. Hello, Coding Room. Yeah, did get a chance to add this to the issues. It's a 3Q. It seems super hard. What is up with this link, Brandon? ClickTuck ML send? What's happening? Give me a better link and I'll check it out. And hello, welcome. And hello, Amhek, welcome. Hello, Subin. Doc says, it seems like half the 1Q problems are compilers. So you want to do any of those? Possibly. So I'll show you the ones that were suggested so far. So there's a 2Q, which is evaluate a mathematical expression. So that's this one, where you're given a math problem, and you must support nested parentheses, and you have to evaluate that problem. You have to count for white space, and you have to like validate the expression. So this is a 2Q, and I definitely haven't solved it before. I think it says train again because I've at least clicked into it. Yeah, the one thing about some of these though, there are not a lot of tests. Like these are basically all of the tests that were given. And so for a hard problem like this, I would probably create my own test suite just to come up with a lot of different scenarios. Thank you, Brandon. I'll click on it in a second. And then another suggestion were these two hello worlds. One's a 2Q, where you have to write the function f that returns the string hello world, but every line must have at most 2 characters, and the total number of lines must be less than 40. So this is just like a weird JavaScript challenge. And so that's the 2Q. And then the 1Q, I think you have one character per line. So you have to write a function f that returns hello world, but every line must have at most 1 character, and the total number of lines must be less than 145. And it's possible to complete this in 99 lines only. So those are a few of the ones that have been submitted. And then, yeah, I think that's it for submissions, but some people sent some in the chat, so we'll click on them. Hey, no worries, Brandon. Yeah. Yeah. Do you not get the party parrot in any terminal by typing curl parrot.live? Oh, did I know? I didn't know that. Should I do it? Let's do it. Sounds like fun. Nice. Cool. And hello, client telephone. Yeah, that's the ditto one. The best dancer on Twitch. Merchon says, it really has been a while, though. Good to see you again. Yeah, good to see you, Merchon. Thanks for dropping by. I'm out of the loop a bit. What does the LED command do? Oh, it lights this thing up. We only did that like 2 streams ago. There's my finger. But if you send exclamation mark LED with 8 bits, it'll turn on the relevant bit. Reduce has been the latest thing the Twitter JS community has been arguing about. What? Can you post a link to a tweet so I can see? What could they be arguing about? Yeah. 3 hello. Oh, okay. And hello again, ATD. That's 4. All right, let's check it out. Is this the one that... I think this is the one that Brandon sent. Yeah, I see. So yeah, because Code Wars... that's another thing about Code Wars. They send out a weekly digest of suggested problems that you should solve. But as you can see, this is like a tracking link with all of the stuff from an email. But that's okay. Let's see what it is. You're given a list/array of example equalities, such as a plus a equals b, b minus d equals c, and a plus b equals d. Use this information to solve a given formula in terms of the remaining symbols, such as formula equals c plus a plus b. In this example, c plus a plus b equals 2a, so the output is 2a. Wow, that looks tricky, but it looks fun. Nah, no worries. A lot of people feel Reduce overcomplicates things, and while it makes code more succinct, that it takes away from readability. I tend to disagree with that sentiment and always prefer to use it over a normal loop. It really depends. When I first started doing JavaScript, I mean, I'd already been a professional developer for like over 5 years, and I didn't really understand Reduce for months. But finally, once I got it, then I tend to solve problems in that way with Reduce. But it's not natural for a lot of programmers, and it is more of like a functional programming thing, which a lot of people aren't used to. So yeah. Math. 8 times 4 minus 9. Hey, so did you build an expression parser for your Alcabot? That's pretty cool. Or does it just use Wolfram Alpha? Of all the compilers, I think this one is the nicest. The others are mostly really time-consuming, especially the BF transpiler one. Uses Math.js. Very cool. Let's take a look. Tiny 3-pass compiler. Okay, you are writing a 3-pass compiler for a simple programming language into a small assembly language. The programming language has this syntax. Interesting. Function, argument list, expression. Argument list. Nothing. Variable arg list. This is like Haskell. This is really weird. Term, factor. Here, I'm going to increase the opacity on that thing so you can see it better. Variables are strings of alphabetic characters Numbers are strings of decimal digits representing integers. So, for example, a function which computes a squared plus b squared might look like a times b times aa plus b. What? This is just too weird. We'll put it on the list to vote, but this is... it's going to take me an hour just to understand what we're doing, but okay. The hardest challenge on Code Wars is navigating their UI. 145 seems arbitrary. Oh, I think I did this one, the SQL way of JavaScript. Yeah, this was the first 1Q that I did on stream, functional SQL. It's pretty fun. I like this one because they have a really good test suite with like tons of things to like kind of to slowly build up your solution. The Hello World 1Q is a bit silly though. There's really only one solution. Yeah. And hello Dana Chu, welcome. Hello Jim. I see you're going after the scary katas. Yeah, that's the plan. We've been live for 14 minutes. I want to get started soon because it's gonna take me a while. I know it. I know me. It's gonna take me a while. So. Brandon says, "Gotta go. I'll check out the video overnight while feeding Dom." Dom is the initials of Brandon's new kid. But yeah, have a good night. Thanks for dropping by. How long was I a junior developer before I got a senior dev position? It's a weird question because I graduated from university, got a job at a large enterprise, got put onto a project, and then like 6 months later, I was the sole only developer on that project. Does that mean I'm a senior developer after 6 months? I don't know. It's a hard question to answer. Yeah, I don't know. And good evening, Jay. Welcome. Whoa, you can do, like, set your variables and then solve it. That's cool. I think reduce is really useful and nice, just misunderstood. I admittedly took a while to understand how best to use it, yeah. A Lisp interpreter would be so much easier. Probably, yeah, because, I mean, this has, like, all kinds of... which one were we looking at? This one. It's all kind of weird syntax. Lisp is just, like, a bunch of parentheses, which is... seems like it would be easier. I don't know. And hello, Rushikesh, welcome. JS doesn't have tail call optimization, so make it yourself. Ooh. Ooh. As a JS user, you know that you're limited in so many ways, so let's break the limit. You're given FD, an array of function descriptions. Your task is to return an array of functions that are able to handle tail calls properly. Each of the elements in FD is a 3-length array having the format. Cool. So a tail call is... it's a recursion thing. So the function calls itself, but you want to prevent a stack overflow. At least that's my initial understanding. We'll dive deeper if we have to actually do that one. So it'll take me 3 minutes. No way. And hello, AK from Bosnia. Welcome. This might be a completely ignorant question, but can you write a kernel in JavaScript? Not really. So there is someone that's trying to create a node.js based operating system. Let's try to find it. Node.js operating system. Node OS. Yeah, the first operating system powered by Node.js and NPM. No, we'll see. This is built on top of the Linux kernel. Probably not. So JavaScript itself is an interpreted language. Technically, you could build a native compiler for it. But basically, you would just need to create a compiler that could take your JavaScript code and compile it into native code to create a kernel. I don't know. It's a hard question to answer. I would say you probably could, but why would you? And it'd also probably be very hard. Indifferent Ghost says, technically yes, but you'd never want to. It's slow. Yeah. Considering JS doesn't really have multi-threading, you might find writing the process scheduler built challenging. I think that's kind of what I'm getting at. Like, it wouldn't... You would have to write your own runtime. You wouldn't be using Node.js or the V8 engine or anything. You would basically... Yeah, there's too much overhead because like it's like levels of abstraction. Like the V8 engine is built to be running on top of an existing operating system. It's not meant to build something that low level. I don't know. Yeah. From what I gathered, you're a really good developer purely due to the fact that you work diligently to solve problems you encounter on stream, and can imagine that transforms into professional work as well. Thank you, ATD. I appreciate that. Yeah, and the other thing is not being afraid to admit that I don't know something, because that's where a lot of like senior developers will get in trouble. Like they'll pretend they know something when they really don't, and then they end up making bad decisions. I will straight up, I'll be in the middle of a meeting and just say like, I have no idea what you're talking about. Please, like, let's get on the same page. So yeah. Acid Spark, hello, says, I've been working on a prototype to try to get more comfortable with Nuxt and Bootstrap. It seems so much more annoying than just writing my own Sass. It's really just because you have to learn about all of the things that are built in instead of writing them yourself. But yeah, it sounds like a fun project. Yeah. I'll link a nice video on Discord from the HTTP 203 show the Google developer guys do on YouTube. It goes more in depth onto the reduced discussion. Cool, yeah, I'll check it out. And hello, Thiago. Yeah, that's the donate link. I don't have monetization on Twitch enabled. What do I think about the future of the .NET stack? I think because it has cross-platform support and it's backed by a large corporation and it's open source, it has a really good future. Like if you were to right now, if you were to ask me would I bet on Java or .NET, I would pick .NET by a huge amount. CJ doesn't have Doc at work like he does here. It's so true. We have some really smart people in the chat. Doc being one of them. Alka, Majestic Eye, a lot of other people that I'm not mentioning are very smart, and they hang out here and they help out a lot. So yeah. The Real Pygon says, I don't know a lot, so that's pretty easy. Hello, The Real Pygon. Welcome. CJ has Alka on speed dial for when he doesn't have something. Yeah, I have him on Discord. All right, let's go ahead and do a poll. So we have quite a few things here. So there's this, we'll include this one that Brandon suggested, this 3Q simplifying, because it looks hard as heck, even though it's a 3Q. We have hello world on one line, or on one character per line. Hello world on for 2 characters per line. Evaluate a mathematical expression. So given an expression like this, we have to write the code to evaluate it. This is a 1Q. We have to create a 3-pass compiler for a language that looks like this. And then we have tail call optimization. So we have to allow functions to recursively call themselves without getting a Stack Overflow. These are the options. Meritron just suggested one from Project Euler. Let's check it out. Convergence of E. The square root of 2 can be written as an infinite continued fraction. Yada yada yada. Find the sum of the digits in the numerator of the 100th convergent of the continued fraction for E. It seems too mathy, honestly. We're gonna stick to Code Wars tonight. Yeah, Robin is definitely another bright person that hangs out over here. And Meritron. Like, if I didn't mention your name, please don't get offended. Like, most of the people that hang out here are very smart people. You call, I answer. But not really because I have no notification sounds, yeah. I had Java on my work computer, and the auto update actually recommended I uninstall it since I haven't used it in 6 months. The Java is like self-sabotaging themselves. That's great. And hello, Rand. Welcome. Indifferent Ghost likes Project Euler. That's good. Okay, this will be the last suggestion, and then we're gonna vote. This is we're creating a regular expression. Regular expression for binary numbers divisible by n. Okay, create a function that will return a regular expression string that is capable of evaluating binary strings, which consist of only ones and zeros, and determining whether the given string represents a number divisible by n. Each n will be tested, random invalid test and random valid tests. Weird. Cult of the Dead Cow is saying, by any chance, do you do any kind of penetration testing software? I don't, no. Mostly we build, on this stream, I build web apps, full stack apps, mainly focused on JavaScript. But I've thought of because there's the social engineering toolkit that's written in Python. I know a lot about JavaScript and node.js, and all the things that people use Python for nowadays, you could use JavaScript for. So I've thought about potentially like writing ports of a lot of the different libraries. That would be a pretty fun challenge. Okay, but we're gonna do a vote. Which kata should I solve? And we're only gonna do one because it's gonna be really hard. It's gonna take me a really long time. It's probably gonna be very painful to watch. Yeah. Here we go. This is a 3Q. Simplify the list of equalities. There. Gets popcorn. This is a 1Q. Hello world. Only one char per line. Do a negative 1Q? I think that's just life. And we're doing that right now, so. 2Q. Hello world. Only one char per line. No, this one's 2 characters per line. This one is a 2Q, evaluate. I guess I should only put one on there. I'm only going to put the 2Q. How about that? Because I mean, I don't even know how I would do it on 1 character per line. I mean, I'm thinking that we're going to have to create basically one functions with a single variable name, and they all like invoke each other. Something like that. But we're going to leave that one off. Evaluate. 2 characters means you can use arrow functions. Oh. 1 character means. Yeah, I think that's the point, is you got to figure it out. So this one, and Mastermind with the raid. Welcome everyone. You're actually just in time. We're about to vote. So welcome to the coding garden. Thank you so much for that raid. But you have arrived on our Wednesday show, which is Code Wars Code Katas. And thanks for the follows. So if you go to github.com/codinggarden/code-katas, this is the 40th episode. We've done a lot of these, where basically I just solve coding problems and I do it live. And today we are doing a very, very hard one. So if you're new to coding, this is probably going to be pretty advanced. I always try my best to explain everything as best I can, but tonight the plan is to solve a really, really, really hard one. So if you go to codewars.com, they have a ton of different challenges that you can do to try and solve. And 8Q is usually the easiest, and then it gets all the way up to 1Q, which is extremely hard. So tonight we're picking a very hard one to try and solve. So this will be fun, and welcome everyone. Thanks for hanging out with us. Thanks for the follow, the few. Rock and Stone. And thanks for the follow, the great Daft Gift. Welcome to the show. These are so advanced, we should just hack some nuclear systems or something. No, we're not going to do that. And hello, Hippo Viva. Welcome. And it sounds like the Mastermind coding school just started on algorithms. So this will be fun. We can talk about stuff. It'll be related. And thanks for the follow, Oyavez and Frontal. And Brixa. Tyler says, I'm scared. Don't be scared. And feel free to ask questions at any time. I always try to explain things. But yeah, we just got raided, Bob. Mastermind is here. Hello. Also, there's lots of fun stuff you can do. So you see these drops that are happening. If you do !drop me space !drop space me in the chat, it will drop your avatar. And if you land right here, you might make it on the leaderboard. And then oh, look at Mastermind coming in hot. And then there's another command you can do. So we have these LEDs that we built like 2 streams ago. And if you do !LED and then do 8 bits, let's do 1, 2, 3, 4, 5, 6, 7, 8. They will light up in whatever bits you send. So yeah, Acid Spark send a bunch of 1s that'll light up those. Yeah, so we have fun here. And then the red chats that you're seeing over here is YouTube, because I'm live on YouTube right now as well. Okay, but what we're doing is we're going to vote on which of these problems I should try solving. So first, you're given this problem, you're given an array of equations, and you have to come up with a formula that basically reduces what's in it. I don't know. We'll figure it out if we decide to do that one. This one, oh no, we're not going to do that one. This one is you have to write a function that returns hello world, but you could only have 2 characters per line. So that's going to be really tricky. Have no idea how we're going to do it if we do that one. And then this one is evaluate a mathematical expression. So you're given a mathematical expression like this, and you have to write the code to evaluate it. It only supports bits. We thought about adding support for like hex and decimal, but right now it only supports bits. Yes, and that's the face I make whenever I get rickrolled, which has happened a lot here. All right, so this is another one. This one looks extremely hard. This is the tiny 3-pass compiler. You're given basically this coding language, and you have to compile it so that it will run. Seems really, really hard. So 1Q, tiny 3-pass compiler, that one. And then this is a 2Q. I don't fully understand it yet, but ultimately we have to implement tail call optimization. So if you've ever heard of recursion, it's possible for a recursive function to have a stack overflow because it calls itself too many times. But with tail call optimization, you can make it so that recursive functions don't would not allow a stack overflow. Tail call optimization? Yeah, it was a 2Q. And then this one's super weird. You have to create a regular expression for validating binary numbers that are divisible by n. All right. Here's here's the poll. So vote now, and whatever has the most votes, I will attempt to do. I don't claim to be the best coder in the world, so if you choose a really hard one, you're probably going to see me struggle. Yeah. Let me catch up on the chat. A lot of LEDs. XCal says maybe I can't solve an 8Q. You know what? You should try though. So and really, don't be so hard on yourself. So a lot of the 8Qs are also like teaching you the basics of whatever language you're working in. So I typically solve these in JavaScript, but if you're learning Python or anything else, you can choose those languages as well. And then if you filter, so if you go to like 8Q and then filter by fundamentals, and then here's the trick. Instead of sorting by newest, sort by most completed. So most of the problems on Code Wars are user submitted, and sometimes people don't describe their problems very well. So if you sort by most completed, and let's choose like 8Q, these are the ones that most people have solved, so you're more likely to be able to understand the instructions. So like this is an example of an 8Q, even or odd. So create a function that takes an integer as an argument and returns even for even numbers and odd for odd numbers. So this is a fairly simple thing to solve if you know about modulus, and you can use the modulo operator. So they get pretty easy, and the cool thing about this site is there's a ton of them, so you can really build up your skills and build up your confidence. So yeah, so don't worry. See, did I miss anything else? Cool, and thanks again for the raid, Mastermind. Much appreciated. Yeah, xCacao wants the equation one. That'll be fun. All of these seem hard. I give up. They all are very hard. So yeah. 1Q seems very interesting considering how addicted I am into interpreting in JavaScript these days. Yeah. Denied. Yeah, that's the fun thing about the drop game is people will like hit into each other. That feature was actually added by a community member. They made a pull request and added the collision detection, which is cool. XKao is saying, what are the gains to solving this kind of hardness? Really, you shouldn't attempt something like this unless you've done a lot of coding and you at least can think about the solution, because otherwise you're going to be banging your head against it. But ultimately, for me, it's just like getting better at problem solving. And it's like a nice reward for understanding such a hard problem and being able to write the code to solve it. For me, anyways. In the real world, like once you get a job in coding, solving things like this, they may not seem totally applicable right now, but a lot of times on my daily job, my work in coding, I'll come across something and it's similar to some problem that I had solved before on Code Wars or something like that. Yeah, regex 1 does seem fun. I don't want to do the regex with the validate. I have source code and it's literally a headache. Hey Josh, what's up? Yeah, they even have Golang on Code Wars for sure. Yeah, Elixir's an option. Yep. And thanks for the follow, Basel, and thanks for the follow, Neuronet. We're here to learn. There you go. I'm not doing any of these. Yeah. I mean, so I've been live for about 30 minutes. This is probably going to turn into like a 2 or a 3 hour stream just because they're hard. And thanks for the follow, Rabizio. Welcome. 3-pass compiler. That's the one that's winning too. That's gonna be hard, but we'll figure it out. I've never written, well, maybe I have. I'm thinking back to when I was in college. I did take a programming languages course, and we built like an interpreter. And I've also built a, like a basic shell in C, like a shell emulator. And we had to parse commands with that. So I could probably figure it out. I don't know. And also, if we look at that, since that one is winning, let's look at it because we can see what tests they provide for us. Let's see. Like not many. These are very, very simple tests. So yeah, we'll have to figure it out. Wait. Oh, I see. So they've provided a little bit of code already. Like, because I was thinking of like a tokenization function. So part of a 3-pass compiler is one of the first steps is to tokenize everything. So you basically get like a keyword and an operator and different things like that. And then after you have the tokens, then you start to do that. But then this is breaking it. So pass 1 is to build up an abstract syntax tree. Pass 2 is to reduce the constant expressions in the abstract syntax tree. And then pass 3 is to return the assembly instructions. Weird. I have not thought about it, no. But looking at it, they broke it down a little bit for us. It should be easy. It's like watching me write hieroglyphics. Thanks, Zoroastrian chemist. I'm gonna have the chat to chat the poll so you don't have to do this 3-pass compiler. Hack the poll? Is that what you meant? I mean, this one could come into the lead. I'll leave the vote. Look, anybody that just showed up, I'll send the link again. So if you go here, you can vote for how hard I should struggle, basically. Oh, cheat. Okay. Hello, my new brain. Welcome. Welcome. Regex for multiples is the best regex to learn regex. Cool. I've never seen that problem before, so it looks interesting. I graduated from university 2011. So yeah. I tried to show you mercy and chose the easy one. Thanks, Majestic Eye. And thanks for the follow, 8-limbed. I suggested the 3-pass one as it's not actually that bad. The hard work is parsing the strings into the grammar. The rest is pretty straightforward. Yeah, we could do it. The voting turnout is too low. Be a responsible coding garden citizen and vote. It's not too bad. I mean, so there are 38 viewers on YouTube and 67 viewers on Twitch. At least that's what my dashboard says. So that's like 40%. That's a pretty good turnout for a vote. And thanks for the follow, my new brain. Robert says, R and Python are typically referred to as the programming languages for data science. Could you make the argument that JavaScript can be used in a similar fashion? So yes, there are math libraries for JavaScript. A lot of the things you can do with R and Python, you definitely could do with JavaScript. That said, the Python ecosystem has things like matplotlib, and R is like a full platform. So like the ecosystem and the community around solving math type problems is much bigger in R and Python, which is why a lot of people use that instead. But JavaScript is a general purpose programming language, and you could use Node.js to solve similar problems. And I don't know if the libraries are as popular, but there are math libraries you could use. So yeah, there's that. Regex is closing in slowly but surely. Having flashbacks to my programming language principles class. Yeah, the class that I took was called programming languages. And at first, I had no idea what it was going to be about. I was like, are we going to learn a bunch of different programming languages? No, we learned about how programming languages worked and how compilers work and all that good stuff. But yeah. Zoroastrian Chemist is saying, my boot camp is teaching CS, and we have to do these types of problems every day. It's the hardest thing for me. Yeah. And hello, Jefferson from NYC. Welcome. Yeah. Are you saying the 1Q? I'm saying it would be potentially easier than some of the other ones that are on the list. Because looking at how they've set this up for us, was it this one? They've kind of broken it down into multiple steps so we can solve each thing one at a time. It makes it a little bit easier. It's still going to be hard. Don't get me wrong. It's going to be hard. Yeah, I only have an undergraduate degree. I don't have a master's degree or a PhD. Anything but regex. Hello, Noel. Welcome. And hello, Cheyenne. It has been a while. Yeah, busy with school. That's good. Welcome to the show. The great Daft Gift Git says, what do I think of Rust? I don't know much about it. I know that, I believe, is it Brooks Builds uses... So I've had Brooks on my stream before. He lives here in Denver. Oh, he's hosting me. Thank you, Brooks. But he's been doing the nature of code in Rust. So that's about my only exposure to Rust. Seems cool. And I've heard people talk about it like it has a totally different. I'm not even gonna talk. I don't really know much about it, but I know that it does things interesting. It's a natively compiled language that does things interestingly. Pandas is an R package for Python. Cool. Yeah. Abstract syntax trees. Yep. Larry NY says, Python has the more computation-intensive libraries written in C. Is there something similar in JS? Yeah, absolutely. So Node.js has the ability to interrupt with C. So a lot of like very performant libraries are actually written in C, and there's just a bridge for calling that code from JavaScript. But let's just search for math on NPM and see what we can get. Mathematical functions, 8 years ago. Math.js. So this is 22 days ago. An extensive library for JavaScript and Node. It features a flexible expression parser with support for symbolic computation, comes with a large set of built-in functions and constants, and offers an integrated solution to work with diff. Let's see. So it has, yeah, a lot of built-in functions that you can use. And if we look at the source code, we can see if they're doing anything native. Let's see. Let's just look at the package.json to see if there's like any build scripts or anything. It seems like it's probably just JavaScript, but I would say it is possible. It is possible to do things like that. Precise manipulation of n-dimensional arrays. I mean, for that, like, you can use things like TensorFlow as well, right? And actually, I think TensorFlow is a good example of something that is using a lower-level interop. Let's see, API. 2.1 stable. Math operations. Yeah, I don't know. How's this poll doing? All right, we're probably just going to do the 3-pass compiler. I should get going. And Cheddar at the top of the leaderboard with a 99.96. Great work, Cheddar. That's good to know. I did a stream the other day talking about worker threads in Node.js. So it was introduced as a stable feature in version 12 of Node.js, where you can actually spin up threads and share memory with Node.js. So yeah. Yeah, so this is an Arduino, and it's actually running Johnny 5. So it has the Firmata firmware. And then we just wrote a simple JavaScript file that can send a command to the shift register over here to light up the LEDs. And then I just have that integrated with my backend API, which is putting together Twitch and YouTube chat. Yeah. My new brain says, I just listened to a podcast about Rust, and I couldn't tell you a thing about it. Yeah. Rust is a cool meme, though. Yeah. Hey, what's up, Brooks? Yeah, I was just talking about you. Someone was mentioning Rust. Yeah, and then ML5JS, which is written on top of TensorFlow. The first challenge with TensorFlow is successfully building it from source. Yeah. Can I explain a three-way merge with simple words in Git? I don't think I've even heard of a three-way merge in Git. I don't know. Yeah, Bob's in the historical leaderboard with a 99.98. It's not the highest. There was one other person that got a 99.98. Yeah, threads are weird. I spent like an hour and a half figuring them out the other day. Okay, so I think we're gonna do it. I'll just refresh to make sure that I have the latest poll results. But the tiny 3-pass compiler has the most votes, so that's what we're gonna do. I'll link it in the chat, so if you want to try and solve it at the same time as me, you're more than welcome. And then you can share your code if you finish it. There's that. Let me get the ibuprofen before this nightmare starts. Yeah. Historical leaderboard. If no parameter in the LED, it sets the ASCII for the first letter of the name. We could do that. Right now, it's only 8 bits. That's all that. That's the only way it works. And thanks for the follow, Stork. Okay. So here we go. Typically, what I like to do is just write the code locally. So Code Wars actually allows you to put your code in here and then click attempt. But I like to write it all locally just because I have more control and I can run it a bunch of different times without having to wait for the result. So let's bring it down locally. And Alka has created a Code Wars API code pin. This thing. So I can take the ID here. It should give me back the slug. This tiny 3-pass compiler. Okay. And you know what? I think... Should I set up a test suite? What do you all think? Let me know right now. First 5 people in the chat to answer. Should I set up a test suite or should I just do like basic console logs? Yes. Yes. No. Yes. The eyes have it. We're gonna set up a test suite. Okay. So I'm gonna make a directory called tiny 3-pass compiler, and then inside of there we'll init it as an npm repo. So if you're new to raise your hand if you're new to Node.js in the chat. Just raise your hand. Type 1 in the chat. Rip people voting on YouTube. I have low latency streaming enabled, but before I get into this, I totally forgot. I've got invisible Jello and a somewhat invisible spoon. If you ever watch Coding Train ASMR, Coding Train has like the magical melon. Alka, do you know what he calls it? He's got like the he has the green melon that space melon. That's what he calls it. Yeah. But this is blue Jello because I have a blue screen. And thanks for the follow, Rof618. Came in at a very weird time, but cool. So those of you that are totally new to Node.js, npm is a package for managing dependencies. In this case, we're gonna have a few dependencies because I want to install a test runner and an expectation library. So if I do npm -y, that gives me this package JSON. And let's see, I do have VS Code open. Let's do this. Let's open it in here. So the package JSON is where all of our dependencies are listed. So right now we don't have any dependencies listed, but I think I'm going to use Jest, which is a test runner and built-in expectation library. So I'm going to install as a dev dependency jest. And you can check out jest on the interwebs, jestjs.io. Delightful JavaScript testing. We'll keep the API docs open for when we need it. There's that. And hey, this is a family-friendly show. Let's not mention things like that. Okay. So we have jest installed. And now let's just create a file. So I'm going to create, I'm just going to call this index.js. This is where our actual code to solve the thing is going to go. So we're going to put that there. And then from Code Wars, I'm going to take this pre-existing code that they gave us. So this is like our base code that we get to work from. And we're going to have to make it work. So there's that. And also, this is using a constructor function instead of the class keyword. Type 1 in the chat if I should convert this to the class keyword instead of a function constructor function. And hello, Greg. Welcome. Just checking to see what y'all are doing. No! Hex says no class keyword. Classes. I'll do it just to show the difference. Like, ultimately, this code is beckoning to use the class keyword because they are using the prototype. This is confusing for a lot of people. So first step, let's convert this to use the class keyword. So in old JavaScript, so any JavaScript before ES 2015, this is how we basically did object-oriented programming in JavaScript. You create a function, give it a name, and then you can put functions on the prototype. And then within that function, you can use the this keyword to access instance properties and instance methods. But the new way of doing that is with the class keyword. So instead of function compiler, we'll have class compiler. And then each one of these functions that we put on the prototype is just going to be like a method right in the class. So put this here like that. So we've got compile. And then we need tokenize. And that goes here like that. And ultimately, this works in exactly the same way. We can create instances of it and all that good stuff. But this is the newer syntax that was added to JavaScript to please all the Java people and C# people that are working in JavaScript these days. So we have pass 1. Got pass 2. Syntactic sugar time. Yeah. Is there a sugar cube emote or emoji? And then pass 3. So as you can see, it's not that different. And like I said, at the end of the day, it does exactly the same thing. This is just syntactic sugar, but now it's in a nice little class. So that's cool. Oh, sugar emote. Cool. Merchant is saying, does the new way change things under the hood, or is it just syntactic sugar? Is there anything you could do with the old syntax that you can do with the new syntax? For the most part, it's the same. The one major difference is the class keyword. Anything defined with this keyword cannot be accessed before it was defined. So the class keyword is similar to const and let in that you can't access it before it was defined. Whereas a constructor function gets hoisted so you can access it before it was defined. AST is an abstract syntax tree. I think we'll talk about that when we get there. And then you can have a constructor. So in this one, the code that I was converting just had a blank constructor, so I don't need to add it. But when you have the class keyword, you can add a constructor and do all of your constructing things in there. But this particular compiler doesn't need a constructor. So yeah, you can do that. It's a lot easier to implement inheritance with the class keyword. Yeah, so with the class keyword, you can do compiler extends other thing. But with the other way, you have to set the prototype of the base prototype of the constructor. But yeah. How about private and protected fields? They don't exist yet, but if you look at the TC39, which is Technical Committee 39 proposals, it will be in the next version of JavaScript. And private fields are going to work like this with the hashtag. the octothorpe, the pound symbol, and that'll give you a private field. But right now, there isn't a built-in way of doing it. Yeah, there we go. Thank you for the link, Alka. All the proposals are there. Let's see. Oh yeah, there's a question. Can JavaScript be used in embedded devices and these devices? I thought JavaScript can only be used in the web. Really anywhere that has a JavaScript interpreter. So these LEDs right here, they were programmed with JavaScript, but what actually is happening is there's a JavaScript program running on my computer, which is right here. Yeah, and you can see all the commands that go through. And it's actually communicating over serial on the USB here. And sending commands to the Arduino to change the LEDs. There are embedded systems that support JavaScript natively, though. There's this thing called Esperino, and it's literally embedded hardware that can run JavaScript natively. So that's a thing. Ariba says, I don't know anything about code, but I watch this stream regularly, and it inspires me to learn. That's great. Thanks for dropping by, Ariba. Yeah, and so Node allows it to run anywhere. So that's a thing. Node 12 already has private fields, so that's good to know. So parsing, I recommend recursive descent for this. I'm gonna do it with like no knowledge of computer sciencey type things. I'm just gonna try to solve it. We should have a competition between all the A-list chat members here doing 1Q Katas for charity. That's not a bad idea. That would actually be pretty fun. Like code for charity. CJ with wings. Okay, recursive descent is a one function per rule in the language grammar that call each other recursively and build up the abstract syntax tree. Interesting. But yeah, we should do a charity stream at some point. That'd be fun. Okay, so we're getting somewhere. We have our class here. One thing I'll do is just say export default. So I want to make this class available in my test file. So by exporting it, I can import it into my actual test file. And then here, let's just create a new file, index.test.js. This is where we can do the jest thing. So I'm just going to do a simple describe, compiler. We'll say it should create an instance. So I'll say const compiler equals new compiler, like that. And we should be able to run our tests. So in my package JSON, I'm going to add a test script. So I'm just going to say jest, like that. And let's try it. Cool. So we have one failing test. Cannot access compiler before initialization. Oh, I should do a capital C, and I need to import it. But I do want to see a failing test before we get going. So this should say compiler is not defined. It is not defined. Cool. All right. Now let's dive into this problem and try to understand what's happening. And also we can convert really quick. Let's just convert these tests here. Oh, wow. Wait, is this giving us an abstract syntax tree? Well, that's pretty cool. Yeah, let's do this. Okay. I'm actually going to add the existing test that CodeWars gives us. What are the class functions doing? Asked DeepSense. Right now, nothing. So we have tokenize that's supposed to split it up into tokens. We have pass1 that takes in the program and returns an abstract syntax tree. Pass2 does this, and pass3 does that. Right now, I think this is doing the tokenization for us, which is cool because we don't have to do that. We just have to work on the 3 passes. The test seems I'm cheating. So the test will help me solve it. They give us an idea of what the expected output should be. So let me just throw this in here and then we'll convert it. So this is an example program that we need to be able to compile and execute. Yeah, able to construct compiler. So we just did that test. And then we need another test for pass1. So really we need these 2 things. It should do pass1. We're gonna try to make better tests, but just for now I'm gonna add what CodeWars has in here. So we have this program And then the pass1 result really is this object. Cool, so this is an abstract syntax tree. It says operation, divide, so we have our divide there. And then I think it splits it up into A and B, so the two things that are being divided. A is first this operation, and operation subtract is between these two operands, A and B. So this gives us an idea of what our abstract syntax tree needs to look like. So once we've done that, then we can say that, we'll create an instance of the compiler. And we will expect that compiler.pass1 with the program to deep equal pass1 result. Like that. And we'll minimize the pass1 result. And then pass2 result is T2 here. Here, this thing. It should do pass2. And really, we have to actually do the exact same thing. So we will move this back out here. These are like our fixtures, basically. And then... Actually, I'm going to do this. I'm going to create a folder for... Because it's hard to see that big old thing in there. So let's create a new folder. Let's call it fixtures. And in here, I'm going to define the pass1 result, which is this big object. Well, I can't do export. I actually messed up. I can't do export default. We're in Node. I need to do module.exports equals that thing. So there's pass1 result. And then that's good. Then we need pass2 result, which I got rid of, which is this thing. And hello, Sharpie360. Yeah, so tomorrow night I'm going to do a live stream with RabbitWorks JavaScript. That's gonna be fun. We're gonna do a little bit of pairing. I'll do like a code review. Okay, so there's the pass2 result, pass1 result, and then pass2 says compiler.pass2 with... Wait, did we set P1? This is getting confusing. Did we set P1 to be the result of pass1? Which is T1. Yeah. So we could pass pass1 result into here to deep equal pass2 result. Like that. We are going to need to import those in. So let's just pass1 result equals require from fixtures and pass1 result. And then the same thing with pass2 result. Okay. And then it should do pass3. So this returns a function, I guess, which takes an input. What is simulate? Where is simulate coming from? Oh, the simulate function is preloaded. Well, I don't get to use that. Scroll down and to the left. Oh, here it is. Simulate. Here is a simulator for the target machine. It takes an array of assembly instructions and an array of arguments and returns the result. Okay, cool. So I can just reuse this simulate function. So we'll do that. Thank you, Doc. So there's our simulate, and then we can write 3 more tests. And actually, while I'm thinking about it, I'm going to install ESLint, because there's a lot of inconsistent stuff happening here. And see you later, ATD. Thanks for hanging out with us. I'm sure I missed a lot of chats. What happened? Do I have to create a new object instance for each test? I might not have to, but I'm going to anyways. Which is also weird because the only part where it's actually using instance properties is the compile function, when compile could have just been 3 functions. So I don't know. Yeah. Cool. No worries, Exacal. Thanks for hanging out with us. See you later. Yeah, there's like a 30-second timeout. Yeah, test for each function. Yep. I also need to parse the argument list and throw an unknown variable error or similar if you encounter something not to pass the hidden empty attempt test. Okay. Can I start an explanation from like 2,000 steps back? We kind of got to get going. I've been streaming for like an hour already. And hello, Totally Sane. It's been a while. What the heck is going on here? We are doing a 1Q tiny 3-pass compiler. Who got trolled? As far as I know, it's running on the thing itself. So yeah. Yeah, I'll zoom out my code. Pass 1 is the hard work. Pass 2 optimizes the AST, and Pass 3 generates the code in a simple language they provide lower down. Cool. Okay. Slowly animating the LEDs. This is normal. No need to panic. Hasn't been that long. I just lurk. Was here for the good portion of the LED project. Oh, cool. Cool. Yeah. I just thought I hadn't seen your name in a while. Okay. Where were we? We're about to write our... Oh, no. I was going to install ESLint. So ESLint is a package to make sure we're coding consistently. And so I'm just going to install that to make sure we can fix things like... Because in JavaScript, both double quotes and single quotes are acceptable. But I prefer to use single quotes. So, yeah. Now we will set up ESLint. We're just going to use the Airbnb code style. We're not using React or Vue, no TypeScript. We're running in Node. JavaScript. Single quotes are the only quotes. Well, that's cool. Yeah, Alka is suggesting a way of doing animations. So if you sent a command like this, it would run each of these one after another. That's pretty cool. Jello is blueberry flavor, yeah. And hello, Be Monstrous. Things are good. The LED code is not on GitHub. I can push it up really quick. Let me just get my linter going, and then I'll push it up. Yeah, see, look at all these linter errors. Let's do this. So we're going to say jest true for the environment, so it knows that we're running in jest. And then we can fix this. There we go. Got rid of all those double quotes. We can fix this. We can fix this. Yeah. This is complaining because class methods use this. This is not going to happen because they're using class keyword when they probably should have just had functions. But I'm going to disable this rule. Defined but never read. Useless escape. What? That's fine. And then the tests. Cool. All right, let me push up that LED code. It's this one. My average FPS is 30. Well, that's good. Thanks, Alka. 8-bit LED. Yeah, the only issue with this Alka is it's really hard to test because you don't have the hardware, and then it's connecting to my chat server, which is only running on my machine. But regardless, use your imagination. Yeah. So if we look at the file, yeah, because right now we get a message, we validate it, and then the main thing that happens is oh, also this is clearing the queue right here. So what you could do is if a message looks like that, you could actually push multiple commands into the queue because the queue is being emptied every 2 seconds. But regardless, here's the code. It's that. All right. What are we doing with our lives? We're gonna try to solve this problem. Okay. One more thing we need to do is actually import the compiler. And I need to not do export default, but say module.exports equals this compiler, like that. And before there are Twitch credentials in the code history. There are not, no. So the that library I just shared, it's using my backend, my own custom backend that is integrating Twitch and YouTube chat, so there are no tokens in there. Let's see. Okay, so that's there. We have our tests. Now we need to create an instance every time. Here we'll expect compiler to be defined. Can I do that? Hopefully. And then we need that one final test that's actually doing the simulation, which is this part here. So we'll create an instance of the compiler again. We'll pass in pass3 with the pass2 result. And then we will expect simulate with the pass3 result. And that input to be, wait, No, to be 3. Cool. All right, so we have our test set up. Now we can actually start writing some code. npm test. All of them should fail except for the first one. So the first one, it can create an instance. That's great. And actually, that last test is passing. We don't want to do that. We actually want to do the full compile. So we'll say compiler.compile. Well, with the program. And that should give us back a result that can be passed into simulate. So now they all should fail except for the first one. Cool. All right, so our very first task is to take this program right here and turn this into an abstract syntax tree. So we can see pass one result is this object. Basically, it splits it up into operations. So we need to take this string. Where are we? This example string, and I guess at first it's tokenized, but then we need to determine like what is the first or like the operation that should happen first. In this case, it's division. So things on the left-hand side of that token and things on the right-hand side of that token go into two separate branches. This becomes A and this becomes B. And then for A, there's an operation subtraction that needs to happen first. So for A, first it needs to do this. This is the left-hand side and the right-hand side. So the left-hand side becomes an operation of addition. Oh, never mind. And the right-hand side is an operation of multiplication. So, wait. No. Addition, and then what's B? Define abstract syntax tree. Yeah, so I mean, we're using an object here to represent it, but yeah, let's talk about abstract syntax trees. AST. And also tokenization. Yeah, we can do both things. Wikipedia. So, in computer science, an abstract syntax tree, or AST, or just syntax tree, is a tree representation of the abstract syntactic structure of the source code written in a programming language. So basically, there are multiple things that we have to do. So the first part, which Client Telephone just asked about, is tokenization. Basically, we take this program, which we're trying to compile, and we turn it into tokens. Like, what are all the valid things that we're going to need to interpret? And so tokenization would first say, like, this is a token, X is a token, Y is a token, Z is a token, that's a token, this is a token. Like, each one of those individual things is a token. You would probably also have like a list of keywords, because keywords are token as well. So if you think about how the JavaScript interpreter might work, in this case, const would be a token, because const is when you're defining a variable. So if we were building an abstract syntax tree for this JavaScript code, we'd have a token const, a token compiler, which is an identifier, so it's like a variable. We then have the equal signs, which is an operator. We then have require, which is a token. In this case, this is just like a function invocation, but this whole thing is the token itself. And so tokenization looks at each individual thing, and then now once we have it broken out into all of the tokens, we build the syntax tree of basically how this thing should be executed. And doc is saying 2 times 3 times x becomes a number of 2, multiply number 3, multiply identifier x. So we're basically breaking down the raw syntax into its individual tokens and identifying each individual thing. So in this actual JavaScript code, this would be like keyword, identifier, operator, identifier, and then like parentheses, and then like string value. Yeah. How does parsing come into the mix then? That is parsing. So the first step of parsing is to tokenize things to try and understand what's happening. And thanks for the follow, Subin, and thanks for the follow, OG Clickbait Nate. Welcome to the show. But I want to see really quick, like, what is the tokenization actually doing? Is that even being used anywhere? Oh, no, I see. It's tokenizing it right here. It's actually just log tokens. And then in my tests, I'm going to comment out all of them except for the second one. So we're just going to do pass one and see if this tokenization works. So they wrote this tokenizing function for us. Let's see what happens. Yep. So the tokenizing function actually already works. It takes the program and splits it up into all of the tokens. And Filtor and Lala with the raid. Welcome, everyone. Welcome to the show. You have found yourself on at the coding garden. And we are doing a Code Wars Code Kata today. Yeah, hype, raid hype. Cool. So if you are new to Code Wars, it's a cool site, codewars.com, with a lot of different coding problems of many different skill levels. Typically, I'll solve some of the more easier ones and kind of like break down solutions and solve them in multiple ways. So they range in difficulty all the way from 8Q up to 1Q. But tonight, we are solving a 1Q. So this is an extremely hard problem. Basically, we are given a program that might look like this, and we have to compile it so that we can actually run the code. And right now, we're talking about abstract syntax trees, so that. This is a 1Q. And this is probably going to be the only one that I do tonight. But yeah, thanks for the raid. Welcome. OG Clickbait Nate says, I've been watching on YouTube, found you through a coding train, and trying to learn backend. Cool. Yeah, welcome to the show. Yeah, and Doc is saying, regarding parsing, consider the difference between 5 plus 5 plus 5, 5 plus 5 plus 5, and 5 minus 5 minus 5, or 5 divided by 5 divided by 5. Order of operations matters. So the first step, tokenizing, is just splitting them up into what they are. So in this case, like numbers and operators. And then the next step would be to build the abstract syntax tree, which adheres to like order of operations, right? I'm using a thing called multi-streamer. If you look up Docker multi-streamer, that's what I'm using to stream to both. Oh, thanks, Filtor. So ultimately, we've just gotten set up. So I pulled the code down locally. We have this. We have our test suite ready to go. And we're about to start implementing pass one, which turns it into an abstract syntax tree. But they already provided this tokenization function, which gives us an array of all of the tokens. Like this. Yeah, I would say so. Would you agree with that, Doc? That the abstract syntax tree ultimately gets created in the correct order of operations, in whatever that may be. Like in this case, we're kind of dealing with math, but you could even think about like a regular JavaScript program. The way it has to interpret things are like, this is the const keyword, this is the name of the variable, this is an operator, and this is the thing that will be assigned to that variable. It basically has a specific order to it. What to ignore and how to process data. Doc is saying the AST is in a way of representing an expression without parentheses and brackets. Interesting. Okay, that's good to know. So, actually, I want to look at the pass one result. So where does the XYZ come into play? Let's like expand everything. So I'll be throwing the brackets away. Okay. So X, Y, and Z are not mentioned anywhere, but I believe ultimately they get put in as arguments. Yeah, so like argument 0, argument 1. So like in this example of the code that we're compiling, these are the arguments that get passed into the function. So x, y, and z, this is argument 0, argument 1, argument 2. And so when we're interpreting this code here, right here, this is actually argument 1. I mean, sorry, argument 0, and this is argument 1, and this is argument 2. Yeah. So Doc is saying you want to chop off and parse the parameter list first, then pass that through so you can validate the variable names. That makes sense. So basically, we're going to look at this tokenization array here, and it starts with a bracket. So we're going to look at all incoming tokens until we see the closing bracket. And we're basically building up a list of all possible arguments. So later on, we can validate that those arguments in here are valid. Let's do that. I think that's the first thing we're going to do. They test for correctly throwing undefined variable xyz when that should happen. Cool. So this will be tricky to test because I want to test that one specific function, but I kind of want to write a test that says should find all valid variables. It should parse arguments. Should parse valid arguments. Yeah. JJJSSS111, hello. Who's asking, how do you complete the kata? They basically have a bunch of pre-written tests. So right now, these are the only tests that we can see that we can, like, if I run the sample test right now, we can see that they all fail because I have, well, all of them except for the first one, because I haven't actually implemented these functions. But when I do an attempt, behind the scenes, they have potentially hundreds of pre-written tests that validate all of my functions. And so if I can get all of the tests to pass, then that means I've written my code correctly. So it's sort of like a micro JS event loop, if that makes sense. I wouldn't call it that because it's not actually running the code. It's interpreting the code so that it can be run, if that makes any sense. Yeah. Oh, cool filter. All right, so should parse arguments. So what I'm thinking is if we do like compiler and then we can like expect compiler dot parse arguments with this string here. Well, actually, no, with an array of all the arguments, because at this point it would have already been tokenized. So like x, y, and z. And let's say there's even more in here, like parenthesis. So I would expect that whenever we parse this, I want to get back an object that has like x true, y true, z true. So just to kind of break this down, the first thing we're going to do is we're going to start parsing this tokenized list. We're only going to look at things between the brackets, and we're going to create an object with all of the valid variable names. So like x, y, and z. Something like that. Let's do that. So now, if we run our tests, it should fail because that function doesn't exist. I'm going to eat some magic jello, invisible jello. Cool. So parse arguments is not a function. Let's make it a function. So on our class, we're going to define a function called parse arguments. And this is going to take in the tokens, and it should parse between the two square brackets. So let's say arguments is an object. This isn't a keyword, is it? I think I can do that. And ultimately, we're going to return arguments. But we're going to look at each individual token. So we'll say really just tokens dot. I don't want to do a for. I want to do a for loop because I want to basically break or out of the for loop when I see the closing bracket. So like ultimately, we're parsing this string here, and I only want to look at this section. So I want a for loop that will ultimately go up to the closing bracket. So let's do this. Let's do a for loop. I is 0 while I is less than arguments.length. Oh no, sorry, tokens.length. I plus plus. Could I split on the square bracket? So they've already given me this tokenize function, which turns it into an array already, which is why I'm expecting it to be an array. Technically, I could split on those two things, but because they've already written the tokenize for me, I'm just going to use it as an array. So I'm going to do like a quick validation. If, and actually here's what we'll do. We'll create a variable. Token is going to be tokens at I. So we'll say I is less than the world. Did I do something wrong? Yeah, so I'm checking for all the things between the opening and closing brackets. So say if token, so I'll say if I is equal to 0 and token is equal to opening bracket, we're actually going to use a continue statement. A lot of people don't like this, but what this does is it'll just go around to the next loop. Because if it doesn't, then I actually want to throw an error. I don't know what error that is, but I'm just going to say like invalid argument list. Like they're missing the very first bracket. Yeah, so say else if I is equal to 0. I'll do this. If I is equal to 0 and token does not equal that, let's throw an error. Otherwise, if I is greater than 0, meaning we've already looked at the first token, then we'll do our thing. So basically each variable in the argument list is going to be after that. So really what I could just do is say if token is equal to the closing bracket, then we need to break out of here because we have found the closing bracket and we've gathered up all of our arguments. Else, we'll say arguments at token equals true. Now, what this should do is because in the simplest case, this gets split up into x, y, z. And so those are going to be all of our arguments and all of our variables. And so we should get an object with x, y, z as true. So Doc is saying this is the recursive descent approach. Accept a square bracket, arguments, accept an in bracket expression. Interesting. Oh, my desktop background is Earth. That's good. I'm still just going to try to solve it. Can I? That's what I was wondering, Anaboth. Let's see. I guess not. Let's call it args. All right. So for this very simple example, this should work. We should get back XYZ as true. To deep equal is not a function. I guess it's just to equal. That's a good call, Kirby Yarma. Thank you. Save the argument ID instead of just true. I like that because so like x is the 0th one, y is the first one, and z is the second one. So let's do that. Yeah, like that. So that passed, but now this should fail because I'm returning it as true. Yeah, but now we actually want to put the argument number. So let's do it here. You would get an error for that. Yeah, I need to reread the description because there's a lot of different potential error cases. The other thing is, what if someone puts a number here instead of like a valid argument name? I should probably need to validate argument names as well. But let's do this. Arg count equals 0. So instead of setting it to true, we're going to set it to arg count and then increment the arg count. So this should give us 0, 1, 2. Cool. But let's look at the description and see what happens, or like see what are valid argument names. Variables are strings of alphabetic characters. Numbers are strings of decimal digits representing integers. Okay, so we should probably validate the argument name to make sure that it's all A through Z, like that it is a valid argument name. Strings of alphabetical characters. So let's do it. Hello, Omar. Thanks for dropping by. So we have it should parse arguments. I'm curious, does it talk about like throwing an error? All test cases will be valid programs, so you needn't concentrate on error handling. Okay, so that's good to know. So we don't have to actually waste the time validating that all of the arguments are alphabetical. So we're going to skip that. Okay, so we have the arguments. That's awesome. Yeah, Doc says, oh, nice. So that's good. We're using Jest right now. So Jest is a testing framework, and describes a test suite, and it describes an individual test. So when I run my test here, the suite is compiler, and then each individual test gets run. Exit is to skip a test, because right now I'm just focusing on this test. So if you put X, it just marks it as that it shouldn't run it. So yeah. Okay, so here we at least can parse the arguments. And I think what we should, so in pass one, we actually could say like args equals this dot parse arguments with the tokens. That's going to give us back the args. But I think this should actually return the index of the last square bracket. So that way over here we can know where to take off from. So I'm actually going to do this. So if the token equals that, I'm going to return an object with args in it and the index I, because that's where we ended and where the index of the last bracket is. And really, I don't need a return statement here. I should probably throw an error right here. Throw new error. Invalid argument list. Ultimately, like if we make it out of the for loop and we never found a closing bracket, then it's invalid. So let's just put this in a variable error message. Hello, KinCode. Welcome. Hola, Jesus. Welcome. Acid Spark says, that's nice of them because I was already at a lot of input error types. Yeah. See you later, Client Telephone. Thanks for hanging out. Like misspelling input. Yeah. Okay, so this is now going to return an object with args and the index of where the closing bracket was, so we can take off from there. So we basically just parse the argument list. Now we will need to parse the rest of this thing. So we just parse that, then we get on to the actual program. And that's going to actually help us build out our tree. But because we have the index of where this left off, we know where to take off from there. So that's what we'll do right here. Okay, so let's look at some other example programs. So I'm curious. Yeah, like this divided by that. So yeah, we need to create these operation objects. So it tells us the operation, what is the left-hand side, and what's the right-hand side. Yeah, reference the nth argument or in integer. Immediate value in or integer. Yeah, so if it's an actual value, it's im. If it's an argument, we put the number of the argument. Arguments are indexed from 0. So for example, the function xy would look like operation division. B is the number 2, so m in 2. And then A is the addition operation between x, which is an argument 0, and y, which is argument 1. Okay. Cool. So I think the next step here is to parse the rest of the string. So anything that is within parentheses, that's going to be its own subtree. Right? Like that operation goes into a subtree. Any standalone number is going to get put into just like a standalone object where it's the im, which stands for immediate, and then the value itself. Okay. This is actually a much easier program, so we can write some tests around this program. And then yeah, so if we start parsing and we see a parenthesis, this is actually going to be the left-hand side of some operation, right? Does that make sense? And thanks for the follow, JJJSSS111. But so if we start parsing right here, immediately I can say, all right, we're now in the left subtree, so we're actually building out A. Then we found our operation, and then we found either a parenthesis or like an immediate value, and we're in the subtree B. I think that's the way to go. Because if we look at like this example problem, it has parentheses in it. This one doesn't have parentheses. I'm curious what the tree would look like for that. Oh, here it is. So add the A subtree to the B subtree. Subtract subtree B from subtree A. Multiply subtree A by subtree B. Okay. PEMDAS. Interesting. So, what I'm thinking is we start now looking at each individual token. So at this point, we found all of the arguments, and we can start looking at all the tokens after that. If we see a parenthesis, we start parsing a subtree. And we parse that subtree until we get to the closing parenthesis. And this actually could be a recursive function because there are more like subtrees within it. Yeah, subtrees sound pretty recursive. Does that sound like a valid option, Doc? Or do you think it's too recursive? Or is that why you're saying recursive descent? Oh, cool. RabbitWorks is linking to the. I totally spaced on that earlier when you were talking about it. Oh, this message was hidden for review. That's ridiculous. But here, RabbitWorks, you can be a mod. You should be able to send links now. Did that work? I think that worked. Cool. Wait, is this the right channel? This is the right channel. Yeah, so this was mentioned earlier, but I got sidetracked. Tomorrow night, I'm going to be on RabbitWorks stream, where we will be pair programming. I'll help them with some stuff and like do a code review. So that'll be a fun time. And this is it. This is it. Cool. Yeah. So tune in tomorrow if you want to watch that. And I believe he does stream on. Do you dual stream to Twitch? But yeah. Okay. But yeah, Doc, is that what you mean? That you were already thinking recursiveness? um. All right. So. Yeah, I'll definitely shoot out a notification in the Discord. Yeah, so at this point we can start parsing, let's call it a subtree. So Doc is saying recursive descent is pretty much make everything recursive. Each rule in that grammar becomes one recursive function. So expression, term, factor, variable, number. Interesting. Interesting. But yeah, I think this could work actually. Because we could say, really we're going to return parse sub tree of tokens dot slice of I plus 1, I think. Because that ultimately is going to return an object, and each subtree has an operation and 2 operands. So we can then start to parse it internally. So that's great. But I plus 1. So my function here will return the index of the closing bracket. So this is going to return the index of this, and I want to start parsing the subtree at the index after that, like at the parentheses one. Yeah, and I actually don't know if I want to call this just yet. But I am going to create a function called parse subtree. This should take in the tokens and also the arguments, because if we come across one, we need to look it up to make sure that it's a valid argument. And then we start iterating. So we can say tree is going to be an object with an operation that is initially nothing, A, which is initially null, and B, which is initially null. And I believe it's called op. Let's see. Yeah, op, A, and B. All the way down. All the way down, all the way down. Really, unless we get to an immediate value or an argument. So there is that. So actually, I'm just going to do this. I'm just going to put the tree has the operation on it. And it may not have A and B because it may actually be an immediate value. So here we go. And And then we're just going to iterate over the tokens to find the two subtrees. And actually, we probably need tree as a default value because it needs to be passed into the recursive functions. So we could say something like tree equals an empty object with an operation. Like that. But then for our subtrees, we're going to pass down, I guess, the parent tree. Or are we? I don't think so. No, we're not. Never mind. Never mind. Forget about that idea. Expression split by plus and minus and calls terms on each part. Term splits by multiplication and division and calls factor. Factor is either a number and a variable or an expression inside the brackets. Should I just look up recursive descent? I kind of want to solve it without that though. Terminal bash says yes. I'm going to try to do it without that. I like the idea of like inventing my own solution. Okay, so really we're just going to need to have a for loop. It's going to go from I equals 0 all the way up to tokens.length. And really, I guess we need to know if we're in the left or the right subtree, like A or B. Okay, but we'll figure that out. And then we're going to have token, which is going to be tokens at I. And ultimately, this subtree just returns tree itself. So to test this, we're going to have like a very basic subtree. Ken Code says, today was a really depressing day in my coding journey. Couldn't seem to figure out any issue on my own, and this doesn't help. This is a very hard problem, Ken Code. Don't gauge your abilities based on this thing. This is very hard. Even I'm having a hard time. Okay, so let's say it should create a AST subtree. And then we'll create a compiler. We'll say expect compiler dot parse subtree. So we're gonna have like a very simple thing. Let's just do like x plus y, like that. And actually, no. Let's just do it with numbers first, like 1 plus 1. No arguments at all. Should create an AST subtree for immediate values. So parse subtree takes in an array of tokens and arguments. In this case, we don't have any arguments, so we're actually just going to pass in an empty object. And this whole thing should equal an object where the operation is plus, and then A is where the operation is immediate, and N is 1. And then B, where the operation is immediate and N is 1. I believe that's what we're looking for. So this expression here, 1 plus 1, gets evaluated to this tree. Operation plus, the A subtree is an immediate value 1, and the B subtree is an immediate value 1. I could put the compiler definition before it. I just don't know if the compiler is going to have any sort of internal state, and that would mess things up because I want each state to be each test to be isolated. Though right now, I actually don't think it has any internal state. This doesn't deserve to be a class. It really doesn't. But I'm going to keep it separate in each test for now. Okay, and I just want to verify, is this how immediate values work? So if we look at like this, operation immediate in 2. Okay, cool. So if we parse this subtree, we should get this back. Yeah, there's definitely like a before each or a pre-test kind of thing, but like I said, I do want these to be created in each test. Okay, so parse subtree. We need to look at each token. Let's actually, I guess let's do this. We'll say if that token is equal to, well, in the very simple case of no parentheses, we actually need to check if it's an immediate value. So really we need to test to see if it's a digit. And I think we can, so it's going to be a string. I guess we could actually just do isnan. The regular expression, this regular expression up here is actually creating that tokenized array for us. We didn't have to do that. But right here, what I'm thinking is we do a regular expression just to validate that, just to see if it is a digit. We also could do, actually I'm very curious. Does the tokenizer keep digits together? Ooh. I'm curious. Because if we have like the number 99, do we actually have two tokens, 9 and 9, or do we have the token 99? I'm curious. Yeah, let me just do this really quick. Compiler dot tokenize program. 99 plus 999. Print the tokens again? Yeah, let's do it. Let's do 99. No, we'll do 81 plus 42. No, we'll do 21 plus 21. And we'll just log the tokens. So this is called calling is it the space that dictates it? The tokenizer actually returns numbers, not strings. Oh, that's good to know. So I could actually just use isnan. Where was this? No, because I'm passing it into parse subtree. Tokenize. And really, I mean, I should pass the tokens in here. That makes a lot more sense. Okay, but let's see what we get. What? Oh, I need to update my test because I had this return the index. So this actually needs to return an object with the args that are that. And I, which is 4. Yeah, I didn't run my test since then, but 0, 1, 2, 3, 4. Yeah. Okay. Now we'll try it. Cool. But yeah, they actually do return numbers. So yeah, that's what doc is saying. So we actually don't even need a regular expression. We can just use like isnan or something like that. Yep, that's it. That's what we get. 21 and 21. So in our subtree thing, let's do something like this. If number.isnan, if it's not nan, then we've found an immediate value. So really what I think we need to do is we need to look at our tree and we need to see if it has an A or a B. So we'll say if A in tree then we've found a B. Right? We're going to take a look at args in a second. Right now, we're trying the most basic. We're trying the most basic program that only has immediate values, not arguments. We'll do a test for arguments in a second. Am I familiar with the shunting yard algorithm? I am not. Manus is saying, I'm running a cron job on Heroku, which should run at midnight, but the function runs at 5:30 a.m. It's probably because of time zones. So it's running at UTC midnight, which is probably 5:30 a.m. your time. So I think. Just check what time zone your server is in. Yeah. The bane of all development, definitely. I'm really trying to think. Do we have an A and a B? But does this actually becomes a subtree, doesn't it? No. But really, if it is a number, then the value is going to be an object where the operation is immediate and in is equal to the token. Like, ultimately, that's what we need to do here. Joe says, I came across an issue at work today. I needed to create a function that validates the date time value that's coming from the backend to be truthy, and I'm using moment. Cool? Yeah. In computer science, the shunting yard algorithm is a method for parsing mathematical expressions specified in infix notation. Well, that's cool. I should probably implement that. All right, we're going to keep going. So far, the loop looks like shunting yard. It's not a very big loop. I gotta write more code. So if that token is a number, then we've found an immediate value, right? But what I'm thinking right now, though, is how do we determine if we put it on A or B? We need some sort of variable that tells us if we're on the left-hand side or the right-hand side of an operation. Really, I could say, though, if tree.op. If there is no operation yet, then we're on side A. If there's no operation, then tree.a equals the value. But if there already is an operation, then tree.b equals the value. Cool. So from here, we can keep going. And then if it was nan, then that means we've potentially found either an operation or a closing parenthesis or something like that. So right now in the most basic case, I'm just going to say tree dot we can say if token is a valid operation. And I think we have a list of valid operations somewhere. Like these. Well, no, this is saying the number as a string. Yeah. Don't leak your keys. It'd be kind of cool if we had a bot that would paste in YouTube chat into Twitch and vice versa. Oh, I see what you're saying. Like, literally take the YouTube chat and... I mean, we could do that. We could make like a YouTube bot that forwards all the chats to Twitch. But yeah. How would I validate the format? Yeah, I would use a pre-existing library. Either use moment or date functions or Luxon, but don't try to do it by hand. Use an existing library, because it's a very hard problem to solve. Yeah. If nan, we can assume argument. I don't think just yet, because right now I'm in a very basic test that is only testing with literal numbers. So yeah. Hello, Kelly. That's just part of the Airbnb rules. They don't like... let's see what the linter error it gives me. It was giving me an error earlier. Let's see. Oh, because I have a syntax error. Unary operator plus plus. So if you look at the Airbnb rules, there's a reason why they don't like unary operators. But I couldn't tell you why. Mind blown? What? Okay. If it wasn't a number, then actually it's the operation. In our very simple case. So then we could actually say tree.op equals that token. We're gonna write a better, like another test to like push it to its limits, but right now, this should actually give us back the tree. For the most basic case, 2 immediate values. I changed the numbers in my test. So this should actually be 21 and 21. Okay. Operation is immediate. In is 21. But the actual operation isn't being set. Like, this isn't being set. So let's see. If the number is not nan, else there is no operation, set it to A. If there is an operation, set it to B. What's happening here? And also, pretty sure I have the Jest plugin, so I can actually debug this test. Here we go. So I want to debug this one, which is saying that. Let's debug this test. Debug. Okay. So we created an instance of a compiler. We tokenize it, and then we get to here. Okay. So our tokens are 21 plus and 21. We're here. Token should equal 21. And it does. That's not nan, so we create this object. There is no operation, so we say tree.a equals that object. Cool. Then token should equal the plus sign. It does. And then that is not nan. Ooh! Oh! This literally checks for the value nan. I guess I just want is nan? This is always confusing in JavaScript, but there's one function that will return, that literally looks for the value nan. Yeah. Whereas number.isNan returns false because it will only ever return true if you actually pass nan into it. Okay, so that's the issue. This actually needs to be number, and well, just isNan, not number.isNan. Unexpected use of isNan. No restricted globals. There's another ESLint rule, which we could probably figure out why that is a rule, but I don't like it, so I'm going to turn it off. Okay, now let's run our tests. There we go. Terminal is mentioning, I could see some possible confusion with I++ and I++ and ++I, where plus equals doesn't have. I think that's probably why they say don't do that. because there are different implications with having plus plus after a variable versus before it, whereas plus equals doesn't. Yeah. Thank you, RabbitWorks. Okay, so we have basic parsing of two immediate values. Now let's write a test to see if it can parse an argument and like an immediate value. So we're going to do a very similar test. It should create an AST subtree for an argument and an immediate value. So if we pass in 21 plus a, then we'll actually pass in an argument where a is 0. And that should actually equal a is 21 is immediate value, and then b is, I guess, arg. Let's see what the expected thing is. Yeah, arg, and then the number of the argument. Yeah, it's definitely wrong right now. We have to actually use the arguments. Yeah, the WAT talk. Okay, so now we actually need to use the arguments. And now we can't just say else here. So else, we actually need to see, is it an argument? If token in args, we're going to do the thing, else we found the operation. So if the given token, in this case, which would be like a, is in the arguments array, then we do some logic like this. We're going to decide which end of the tree it goes on, and we'll define our value. So value is an object. The operation is arg, and the number is args at that given token. Like that. This should do it. Cool. Now let's try to parse a subtree with 2 arguments. It should work, but I mean, actually should work without any extra code. So if I do b plus a, and then a is 0 and b is 1, then we should get back 1 and 0. So it should create an AST subtree for 2 arguments. Cool. I think the next thing is I want to actually start parsing like parentheses and stuff like that. So at this point, if we were given this, we wouldn't know what to do with it because we see like an opening parenthesis. So we need to start accounting for that. So if we see an open parenthesis, we kind of need to parse all the way to the end of the closing parenthesis and then create subtrees based on that. And here, this is going to be 2 is going to be in the left subtree. The operation is multiplication, and then the right subtree is actually itself a subtree with with an operation. Yeah. Crazy. Every time I see Nan, I think of Grandma. Though, let's see if we can parse. Let's try to parse this into a subtree. This is a little bit simpler, and we'll expand beyond that. But I'll say it should create an AST subtree for an expression with parentheses. So create a compiler. We get our tokens, which is going to be this. And then we parse them like so. Let's just call x 0 and y 1. Oh no, y is 1. So this should give us back an AST with the operation division. The A subtree is actually going to be itself a nested subtree, where the operation is addition, and then this has an A and B on it. And then B over here is an immediate with the value 2. And actually, this is kind of our subtree for x plus y. This is 0, and this is 1. So when we parse this, we actually have two subtrees. The first one is on within parentheses, and that's here. That's A. And then B is just an immediate value 2. So there's that. And the overall operation is division. Okay. And yeah, this fails. This probably fails miserably. So let's try to handle it. Really, if the token is a parenthesis, we're in a new subtree. And I think this is where the recursive call would come into play. So if it's not nan, we've found a value. If it's in arguments, we've found an argument. We'll say if token is equal to that, or really, if it's equal to an open parenthesis, then we need to do a recursive subtree. Right? I think the only time we recurse down is if the parentheses open. Because we'll call it recursively with all of the tokens up to the closing parenthesis. And then we'll continue parsing from there. I think that's the plan. So you all counting up? That's awesome. Or are you counting up? Yeah, maybe. So if the token is an open parenthesis, what we're going to do is we're going to do a recursive call that includes the tokens up to the closing parenthesis. So we're going to say tokens dot slice turns a section of an array in this case. So we want to get the array that's from the current index plus 1, because we don't want to include the opening parenthesis. And we want to go up to the closing parenthesis. So I believe there, if we look at index of, not on MDM, on MDN, there's also like first index of or something like that. But array.index of, it returns the first index at which a given element can be found. So if we get the first index of the closing parenthesis, let's do this. Subtokens is going to be that. And then we're going to go up to the closing parenthesis. What about nested parentheses? It's going to be a recursive call. Easy. Oh, you're right. We don't want the first closing parenthesis. We want the closing parenthesis for this group. which means we need to look at every token, and if it is an opening parenthesis, then we know that we're going to need 2 closing parentheses. So you're right. Yeah, Asset Spark has it. Let's do it. Okay, it's not going to be as easy as I thought. I want to do this. I'm going to have an array of subtokens, and then I'll have a paren count, and that starts off as 0. So we're just going to go from, let's call it j, because we're in a loop inside of a loop, and that's going to start off at I, while j is less than tokens.length, because we could end up going all the way to the end. And then we'll have a nested token here. And really, we want to go from I plus 1 because we don't want to include the opening parenthesis. Let's call this sub token. And sub tokens. And we'll say if sub token is equal to an opening parenthesis, we're going to say paren count plus plus. We'll do the plus equals 1 thing that they want. So if we found an opening parenthesis, we're going to increment. If we find a closing parenthesis, we'll say if paren count is equal to 0, then really we need to just break. Because if we find a closing parenthesis and we never incremented, then we actually did find the end here. So we're just going to break out. Else, paren count minus minus. Oh yeah, we can definitely put this into a function. I think we'll do that. So if it's not that and it's not that, well, and then otherwise we just say subtokens.push subtoken. So yeah, so basically all of this just needs to be a separate function that I should probably test individually. But let's just see really quick. So this is going to grab the token. If it's an opening parenthesis, in this case, we already skipped the first one, so we would want to push that in. If it's a closing parenthesis and it is the last one, we won't push it in because we're going to break out. But if it's inside of it, we would. Okay, so now what we can do, now that we have the subtokens, is we can say value equals this dot parse subtree with subtokens and the arguments, like that. And then we can just do this same little logic right here. So if there's no operation, then that resulting subtree is going to be A. Otherwise, it's going to be B. Now, all of this we're going to put into a function. Refactor. Why won't it let me refactor? Well, okay, we'll do it by hand. But basically, parenthetical denial of service. Each subcall will be repeatedly scanning over the same brackets. This is true. Yeah. Though I'm pretty sure we are only given valid programs though, right, Doc? Gotta do this one step at a time. So we're gonna create a function, this.get subtokens, that does all of that logic with the given tokens. And we get to pass in I. This dot this. Did I put that accidentally? No. But we'll pass in the tokens and I, because that's where we need to start off at. And then ultimately we're going to just return, and here we won't, well, yeah. We'll return subtokens like that. Parenthetical denial of service. Delegate it to the recursive function to be specific. Are you just giving me a hard time, Doc? I don't think we're gonna see any problems like that though, right? Cool. So that's gonna give us the subtokens. Then we can get the value out. This might actually work. It doesn't. Subtoken.push is not a function. Subtokens.push. What if I just return the index of the closing parentheses in the recursive call? Oh, I totally forgot. Yeah. So, now that we're doing this, this loop here, I should now be a different value because we just got the subtokens. So this actually needs to return subtokens and the index where this thing should pick up from. Call it next index. Here, and then we'll say, do all of this stuff, and then I equals next index. -1? No, we'll just return the next index. So, right here, instead of breaking, we need the index that we're at. So we're going to return an object where the next index is j. We have our subtokens. And then, well, yeah, here we don't need to do that because it's a return. And then here, we're going to just return subtokens and next index at this point. Because we made it to the end of the array, it's actually just tokens.length. Like that. So at this point, because we're parsing like a subtree with the parentheses, we're resetting where I should take off from when it starts looping again. Let's try that. So Doc is saying parse subtree should return the subtree and the index it read up until, which is either a closing bracket or the end of the string. Well, the thing is, it always reads to the end of the tokens that it's given. So this ended up working because what will happen is when it gets here, so right now it finds the open parenthesis, it then parses this subtree. And then in the previous recursive call, it picks up from there and parses the rest. So this is now working. So yeah. But does the sanitize library also do validation? I don't know what you're talking about. Okay, so we have basic parsing of functions like this, and technically, this should work if we have two nested subtrees. Let's actually try to do that really quick. So if we do like x plus y divided by x plus y. We should actually get back this same subtree for both. Oops, not that. X plus y with a division sign. Cool. Now if we did nested parentheses, is that a thumbs up for me, Doc? Because you didn't think my code would do it? Thank you. If that was for me. But now I think it can handle, I think it technically could handle nested parentheses, right? So if we, let's try this even deeper. So if we do x plus, and then inside of here we do x plus y. So this is x plus y, right? Which means we're going to have argument 0 plus x plus y. That works. Yeah. So we've got that working. What else? This. But technically, this is an entire subtree. This section here. Basically just variations of what I did. So yeah, because what we've written so far could parse this. This is going to be two subtrees with division, right? Yeah. And then here, we're going to have this plus that. The difference between triple equals is security and validation is between sanitize, security, validation, business rules. What? I think that was related to something else. Okay, but yeah, I'm just handling things with two operands. So like A and B. Now, what happens if we do something like this? We have a scenario where basically, so this gives us A plus B. And then if we come across, if A and B have already been set, and we come across another operand, then we have a subtree, right? So how can we test this? I mean, really, testing it with like 2 times 3 times x. Something with multiple operands instead of just one. Let's try to do that here. It should create an AST subtree for more than one operand. Like, what I'm thinking is something like x plus x plus x. And really, let's just do it with numbers first. So like 3 plus 3 plus 3. There are no arguments being passed into this. And what we should get back is an operation plus with, I guess this is a subtree with A and B. Katas are more about testing than problem solving, it seems. I mean, I am problem solving. I'm just writing tests that solve small problems as I go along. So this subtree adds 3 and 3, and then B here is just an immediate 3. And Trevor Blades with the raid. Welcome, everyone. We're deep into this code kata. Yeah, and Cheddar definitely is at the top of the leaderboard. But welcome everyone. I am currently solving a problem where we have to build a 3-pass compiler. So we're given an expression like this, and right now we're working on turning this into an abstract syntax tree. And then our next step will be to simplify that abstract syntax tree. And then there's like one more step after that. But we're still on the first step. It's a pretty hard problem. But this is actually a Code Wars problem that we're working on. This one. I'll share it now. Yeah, and what's up, Trevor? I'm I'm doing good. This is this is a hard problem to solve. We're doing it in a somewhat test-driven style, so I'm just writing small functions and testing them, making sure we're getting the right output. But yeah, in steps away from writing our own compiler. At this point, so they gave us the tokenize function, which is nice. So that's going to take a string like this and turn it into an array of tokens. And right now, my abstract syntax tree can do basic things. So like given the expression 21 plus 21, it will give you back an object where it says the operation is plus, the A branch is an immediate value 21, and the B branch is an immediate value 21. So we can parse basic things like that. Now we've started parsing arguments. So given an expression with like variables, you can pass in a list of all of your arguments, and it'll parse it in the same way, but tell you where you need to pass in an argument or where an argument should be looked up. YOLO. And then we got it working with parentheses as well. So this is a slightly more complex abstract syntax tree because you have two sub branches. So this is like branch A and this is branch B, and they're being divided. So the operation is division. Branch A is the addition of argument 0 and argument 1. So that's branch A. And then branch B is just the immediate value 2. So we have that working. And then we have multiple parentheses working and nested parentheses. And what I'm about to try to get working is more than just one operand. So like 3 plus 3, it's easy because that's like the A tree and the B tree. But 3 plus 3 plus 3 is, yeah, like you have one subtree with 3 plus 3 that's being added to the outer subtree. So we need to figure out how to handle this. And actually, basically what happens is we reach a number. I guess like right here. So if we found an operation, yeah. So if there was no operation, then we set it. Else, we just I've done more researching than working. Cool. Oh yeah, and we have this new command in the chat. So if, you might have seen people doing it, but if you do exclamation mark LED and then do 8 bits, either zeros or ones, it'll light up the corresponding LEDs here. Yeah, so there goes terminal bash. 10011001, and each of these LEDs represents a bit. So if there was not an operation, then set the operation. But if we just came across an operation, and we've already seen an operation before, we actually need to parse a subtree, right? So like in the 3 plus 3 plus 3 example, at this point, 3 plus 3 plus 3, at this point, we have this subtree here. We've calculated that because we made it that far in parsing the tokens. So we have this subtree here. And what we need to do is take the current result or the current tree and put that on a new subtree. Yeah. Something like this. Well, Well, I think what we need to do is we need to create a new tree. So really, we need to be able to reassign this. So I'm actually going to say tree equals this, where branch A is equal to the tree itself. And then we'll need to set branch B, and then the operation is the token itself. Because we would have reached that point right here. So now branch A is this, our operation is plus, and then we come back around and we found a token, and that becomes B. So this will solve the simplest case, I think. Yeah. Sean is asking, what about the order of operations? If you have 3 plus 33, would it rewrite it as 33 plus 3? No, in this case, it always parses from left to right. So let's see what Doc is saying. Also, 3 plus 3 plus 3 is equal to 3 plus 3 plus 3, but 3 minus 3 minus 3 is not equal to 3 minus 3 minus 3. Yeah. And so right now, our parentheses rules should adhere to that, because this is going to be considered one subtree where that will get calculated first. And this will be another subtree. Yeah. So I think we're doing pretty good. I mean, at this point we have I have cat whiskers. Yeah, these are my whiskers. Hello, panda person TTV. Welcome. And thanks for the follow. Okay, so like if we parsed 2 times 3 times x, I think we would get the same thing. But let's try parsing something like this. 1 plus 3 plus 2 times 2. And we have the result of what the expected value should be. So it should create an AST for mixed operands, let's say that. So we create a compiler. Grab our tokens. Compiler.tokenize with this. And really, we would just be looking at that. Yeah, DeepSense says, lexical analysis is the first phase of a compiler. It takes the modified source code from language preprocessors that are written in the form of sentences. Yeah, so are we doing lexical analysis right now? I think so. Cool. So we can look in our result. We are not doing lexical analysis. Okay. To see what this should output, but this is where a lexer equals a tokenizer. Okay. But this is where order of operations will come into play, because we actually need to do 2 times 2 before we do 1 plus 3. I'm just curious what we're actually going to get back. Let's just do this. Compiler dot pass. Dot parse subtree with our tokens and no args. And we're just gonna log it. I have a feeling this is not gonna. It's gonna work, but I don't think it's gonna be in the right order that we would expect. So we have multiplication of 2 times the addition of a plus b plus 2. And this is wrong, because it should actually multiply to the 2 first. So we'll get to that. But Panda Person asks, what am I using for these? It's an Arduino. If you look in my live stream archive, like 2 streams ago, we built it live on stream. But it's an Arduino. It's running the Fermata firmware, and I have a Johnny 5 program that's listening for chat messages from my combined chat server, because I have chats coming from YouTube and Twitch at the same time. Always bracket 3 up, 3 up, 3 up, 3, 2, and I'll be fine from minus and divide. So for subtraction and division, I can just always assume that there's going to be parentheses in it. I can like add my own parentheses. You know I'm on a roll when I'm past line 200. Well, we're writing a lot of small tests. And honestly, the fact that we can parse this into an AST, abstract syntax tree, I'm pretty proud of. Like, that's pretty cool. However, we're not listening to order of operations yet, so we need to fix that. Oh yeah, that's a good call. Because you can see right now in my console log, it's just listing these as object. But if we use until.inspect, it'll go way deep. Let's do it. And then I think util is just built into Node. Nice. Okay, so this is what we're getting back, but we can look at the actual subtree in our pass1 result, I believe. So this is going to be our B subtree. Subtree to equal that. So, and actually, if I just run this, we should see where it went wrong. Oh, thanks, Deep Sense. Thank you, Nerdette. I'm trying my best. I've been streaming for 2 hours and 46 minutes. We're gonna at least get past 1 working. I might have to end the stream though. But let's see. You know what? No, I'm just gonna log it because it's really hard to tell where it went wrong. But ultimately, I think even if we look at this, so we're looking at this problem here. The multiplication has to happen first. So really, we need to find multiplication and do that first, because that goes into its own subtree. And then we go out from there. So once that's in its own subtree, then it's easy enough to just make this a subtree of 1 plus 3, like that. Yeah. So, and at this point, see the 2 is getting added to 1 plus 3. When in actuality, 2 should be multiplied by 2. Infinity. That could result in like a Stack Overflow, right? Or like a Stack Overflow? Yeah, maximum call stack exceeded. If there's like recursive references, it's smart enough to handle it. And so if I do that, what you're saying is that I can just do console log and I won't have to pass in the options. Here. Yeah, look at that. Would you look at that? Nice. Okay, so at this point, what we kind of need to do is in our so we have this get sub tokens thing. Parse subtree. What we need to do is adhere to order of operations. So we should really only start parsing things by order of precedence instead of just like automatically doing it. So how do we do that? My table of grammar rules. I don't have one. Should I make one? See you later, Trevor. Thanks for the raid and thanks for hanging out. Expression plus term or term. Term times term, factor, expression or number, digit. I think I get what you're saying. Like, these are all the possible things. Check both the left and the right side and decide where to start. Neuronet is saying sort the subtrees by operator. So right now, the grammar table expresses precedence, like with multiplication. Okay. Doc is saying the main approaches for hand coding are recursive descent, shunting yard, and precedence climbing. I feel like I've solved a kata like this before. I don't know if I want to go look at that code, but we have solved something like this before. Pass a subtree to a function and get back an answer considering the order of operation inside the function. The thing is, at this point, we found this little, like the value itself, which is the number. Doc is the MVP for sure. Okay, so for example, if we're looking at this expression, we really need to look at every single operation and find the operations that matter and do those first. Right? And that becomes its own operation subtree that then you can just do the rest and that'll just happen naturally. Yeah, so find multiplication or division first and do those. I feel like I've solved a problem like this before. Okay, I'm gonna go look at some of the previous katas that I've done. I may not use the code, but I'm at least just gonna look at the code to see what I did. Just to see. Sum arrays. Interleaving arrays. PIMDAS? Who's talking about PIMDAS? Playing with digits. What is this one? No. Is it 37? 36. 35. I really feel like, I don't know how recent it was. That's Sally. She's a monster, always needing excusing. PIMDAS? Is that what you're saying? Hello, Oscar. Welcome. Past CJ was wiser. Yeah. I feel like I parsed some equations at some point. Functional SQL. Oh, please excuse my dear Aunt Sally. That's order of operations? I thought about that for way too long. But, yeah, I guess that's order of operations. I'm trying to think what the stream was where we did that. Playing with sets. Please eat my delicious sandwich. Basic mathematical operations? That was only an 8Q though. Yeah, that one was too easy. It wasn't this far back. Okay, I don't remember it. But I feel like we've done this before, where we were determining order of operations. But yeah. Recursive descent. So, I mean, I guess we could just implement recursive descent. I'm already down this path of, like, solving it without having any idea of what I'm doing. So, maybe we just keep going down that path. But I think ultimately we need to find the first operation to do. So, please let me know if I'm accurate in thinking this. If we look at an expression, we can look at it from left to right. And the moment we find either, like, multiplication or division, we should we can execute that, or like do that expression, evaluate that expression with the things on both sides of it. Private eye might detect another sleuth. Is that accurate? So we could basically, once we come across one, we now have like a left, we have the left operand, and we have like a totally separate left subtree, but we can evaluate or begin to evaluate that one thing once we find it. Because if we had like plus 6 divided by 3 times 3. So if I come across this, I would actually evaluate this. And I know that we're not evaluating it, we're creating a subtree. But this would become its own subtree of 2 times 2. And then this would become its own subtree of 6 divided by 3. And this would be another subtree of that multiplied by that. And then that entire subtree would be added to this subtree, which is added to this subtree. Mathematically, yes. I'm eating my invisible jello. Okay. I mean, would it make sense? Let me know, Doc. Would it make sense to take the expression and add parentheses to it, so that way it would make it easier to evaluate because we already have parentheses? So this becomes, for parsing left to right, that's 2 times 2 times 2 times 2, and then that whole thing gets added to 1 plus 3. Yes, you can definitely do that. Okay. So, if we took something like this becomes 2 times 3 times x, like that, plus 5 times y, minus 3 times z, plus 2 times 2, and then 1 plus 3. Yeah, because I think actually if we add parentheses, my parser might actually be able to handle precedence already because of the way we handled parentheses. Um, so I think I had this, right? 1 plus 3 plus 2 times 2. Because actually, if I made this into this, I think my, yeah, so see, it can handle that. Because if we convert it into that, my thing can already do it. The test is passing. I'm looking at the check mark there. Because basically, my parser already looks at nested parentheses subtrees and evaluates those. I think that's the way to go. I think like we're already this deep into it. We should put parentheses on it. And Doc is saying there's a direct method for adding parentheses here. And you can also convert an infix expression to reverse Polish notation and then just parse that left to right. I've talked about that before on my stream because we did solve a Polish notation or create a Polish notation calculator. What if the tests don't have the extra parentheses added? We're gonna add them. So I would basically write the code that says before I start creating my subtrees and before I tokenize the program, I'm going to add in parentheses myself before I tokenize it. So at this point, we're given just the plain text program, so we should be able to add the parentheses if they don't exist. That's the plan, anyways. Let's see these algorithms. So that's Dijkstra's shunting yard algorithm for converting infix to postfix, and then you can just walk from left to right using a stack and omitting all the brackets for the other RPN method. There are other ways to apply operator precedence rules. One is to build a tree of the original expression and then apply tree rewrite rules to it. Another approach is to first fully parenthesize the expression, inserting a number of parentheses around each operator such that they lead to the correct precedence even when parsed with a linear left-to-right parser. Yeah, so this is what I'm thinking I'm going to do. And this algorithm was used in the early Fortran compiler. So we're basically making a Fortran compiler. Would expand each operator with the sequence of parentheses in a simplified form of the algorithm. It would replace plus and minus with add blank blank at the and after each left parentheses in the original expression, and that at the end of the expression before each right parenthesis in the original expression. It's a really simple algorithm. We could do that. Even Donald Knuth approves. Yeah, in the words of Knuth, the resulting formula is properly parenthesized. Believe it or not. Well. I'm curious, can my program handle all of these extra parentheses? Well, yeah, we'll try it. We don't want to do the yeah, I don't want to do the power operator because we don't have that in this language. So it should create an AST for with many extra parentheses. Fingers crossed that it works. Thank you, Terminal Bash. I don't think it will. I think I have to handle like what happens when there's just like literally nothing with a bunch of parentheses. So we can say like tokens equals compiler dot tokenize. And instead, let's just do C. It will work. C times. What were the rules for that? This kata should assume for expressions are parenthesized properly. Okay. I mean, honestly, though, we could just test it simply with this. Or is that too many? Got A, B, B, and then that. Yeah. You got this. Thank you, Ashwin. Paste it as JavaScript to see what ESLint will tell me. Okay, like let A equals 1, let B equals 2, let C equals that. Ah, ESLint doesn't care. Oh, because I have a syntax error. What about this? Operator must be spaced. That's about it. That's all that ESLint cares for. That's funny. No, log the subtree. So ideally, this should just give us a subtree. This should give us a tree with the operation multiplication and the. Oh, we need to pass arguments into it. Like that. It works? Oh, because I'm just logging the tree. But I want to see what I get back. Hey. It's close. There's a bunch of empty operations. At least it didn't crash. But Ashwin says, any more plans with the LED commands? Yeah, so I ordered actually a bunch of cool little hardware things. I got more of these. That. Because last time we had a really hard time figuring how we were going to even program these. I figured out how, and we can use the shift register, multiple shift registers, but I ordered like an entire, like four of these long, and they all have the max 7219 chip, which makes it really easy to program. So we can make an entire like thing like this with like scrolling text. I also ordered some RGB LED matrices, and then another thing, which we probably won't do like anytime soon, but eventually a really, really cool Arduino project, which I'll save you for. Fix the thing case and the rest will follow. So if you have an argument wrapped in parentheses RGB, yeah, it's gonna be fun. So in the plan is all of these things that I build will be controllable through chat, just like the LED there. Fix the parenthesis A case. So we already have scrolling text though, but in a physical form. So if I just handle like if I handle an argument that's wrapped in parentheses, that would give us, there would still be one extra. I don't know. I mean, can I think up an easier algorithm for this? But also, I just want to see really quick. If I do parentheses in the most basic form, like this one, will that equal what I was expecting? Because like this is not like all the extra parentheses. This is just like minimum number of parentheses. See, that works. So our test program, which doesn't look like this. Let me pull what the expected program is. This this program here. So if we convert this into parentheses in the most basic form, then we're good to go for step 1. So I think I might try to do that. Like, instead of doing this, like, all these extra parentheses, if we can just get the minimum number of parentheses added to the program. Let's see. So Doc is asking, can I test what that parses to? Okay, let's try it. Where are we? Here. Do you mean like that, Doc? Oh yeah, my break timer isn't running at all. There we go. I probably need to take a break. I've been coding for 3 hours. Yeah, I think I do. But also if we do like, even like, well, no, at this point it shouldn't have parentheses. It would have got passed in without them. Like that. Yeah. It should be up im, but I'm getting up im. Yeah. So really I need to look at a open parenthesis, and if the next value is converted to complex and then simplify it. Is that possible? But it should be, yeah. So if I come across an open parenthesis and the next token is an argument or a number, then I handle that as a special case to just grab the argument, skip the opening. Because let's see what I'm doing in the case of open parentheses for parsing the subtree. So if the token is equal to an open parenthesis, then we get the subtokens and parse the subtree. And hello, Herman. Welcome. But if the open parenthesis is followed by a token and then a closing parenthesis, it should not create a subtree inside of the parentheses, yeah. Discard bracket pairs around the entire expression. I'm okay with that. Yeah, actually, I like that. I was expecting that at this point, we had already done that, but I guess not. And hello, Yash. We're working on a Code Wars problem. It's actually a really hard one. And I'm having a hard time. We're only like a third of, not even a third of the way through, but this is the problem that we're working on. Okay. Well, first character and last character equals brackets. Slice off the first and the last character. Yeah. I'm trying to think if that would mess with any of the other things, though. Like this. Because if this gets rid of the first and the last character that are brackets, we now have a broken expression, right? Because it would be given this entire substring. and it would slice off this one and this one. Oh, but really, I would just want to see if it's a valid matching pair. So like opening and closing. Like in this case, I wouldn't discard them because they belong to two different pairs. Yeah? Matching bracket pair code. I think, oh yeah, I'll do this right here. So, instead of calling the recursive function, I could just do something like this. If tokens at I plus 2 is equal to a closing parenthesis. So, right now we're at index I, which is the open parenthesis. If we see a closing parenthesis that's just 2 away, then that means we've wrapped a value in that. And if that's the case, then yeah. See what Doc is saying. So what you're thinking is we do an initial pass to remove all the extra parentheses on the edges. Do the discard in my existing matching bracket pair. So I mean, if we did that in this scenario, we would get rid of all of the opening and closing brackets. Okay. So if the first token if the first token is an open parenthesis, then we want to with more than one, yeah. So there's a prior step to this, which is tokenization, and it takes care of multiple digit numbers. So in our token array, a multiple digit number would still just be one index in the array. But are we thinking this, Doc? So before we actually go into parsing the subtree, we're going to remove opening and closing parentheses on the end if they're a matching pair. We basically would have to do one pass to do that. If tokens at 0 equal that, let's say clean tokens with tokens. Think, right? Right? I'm not gonna, no. I'm done. Well, I'm tired. I'm not done. I'm done trying to do it this way. I think what I want to do, because we already showed that it works, is I want to try to add parentheses in the simplest way possible. So like this. Right? We look at our tokens. I probably need a break. I've been coding for over 3 hours now. But we look at our tokens, and if they're separated by multiplication, we add the parentheses. Then we keep looking. Then that would add parentheses there and there. There and there. There and there. There and there. Yeah. Yeah, I think so. I think at some point I end up just writing another parser. Yeah. It's like I'm trying to get what I have already just like working. Um let's think of a way to take this. I mean, ultimately this would be, should we try to modify it after it's already become tokens, or should we modify it before we tokenize it? Like, should we actually modify the string itself? I think we might actually do it after tokenization, because at that point we already have all the validation of like operands and stuff like that. But yeah, I don't know. I probably need to go. Gotta go to bed. I have done a reverse Polis notation before. How do we... So is there an algorithm for converting something like this into reverse Polis notation? Is that what you're saying? The shunting guard algorithms. You mentioned that at the beginning of the stream. I'll finally look it up. I don't know why I didn't look it up to begin with. Is a method for parsing mathematical expressions specified in infix notation. It can produce either a postfix notation string or an abstract syntax tree. That's really easy, right? Um, so 3, add token to the output. Push token to the stack. Add token to the output. Push token to the stacked. X has a higher precedence than plus. Cool. Add token to the output. And then, wait. Ashwin is asking how I use the exclamation mark wiki. It's because I have DuckDuckGo as my default search engine. So they have a shortcut. Those are called bang commands. They're pretty cool. That's great. And then I guess the thing is, once I have reverse Polish notation, I would have to update my parsing, my subtree parsing algorithm, because we then end up with an expression that looks like this. But that would allow us to do it in the correct order of operations. X multiplication plus Z. And hello, Yuvaraj, welcome. LED blast. Okay. I'm curious what's happening here, though. So 3, 4, and 2 all get put into the output. And then we get to division. So because division takes precedence, we pop the stack to the output here and push the token to the stack. Okay, so when we find something that takes precedence, like division, we do that. So it goes over here, and then that one goes over there. we have a parenthesis, so we push the token to the stack. A 1, subtraction, a 5, and then a closing parentheses. So because we found a closing parentheses, we pop the stack to the output and repeat until the opening one was found. So 1 minus 5, closing parenthesis. So that's going to give us the negative, which is on the outside of the parentheses. So that goes into the output. And then pop the entire stack to the output. So the result of turning this into reverse Polish notation is this. Cool. We don't have to worry about raising things to a power. And then, yeah, once we have that, I would have to update my subtree algorithm. But at that point, it just can read it from left to right. It's always going to be in the right order of operations. Cool. And hello, One Pocket Pimp. I'm kind of exhausted. I've been coding for 3 hours without a break, and we're only like a third of the way through the problem. So this is postfix notation because the operator comes after or post the two operands, whereas prefix notation will have like 3 plus 4. There's a really good number file video on it. Prefix versus postfix. I think I said that right. Let me know if I'm wrong. Definitely check out this video. It's really good. Okay. Should I... What should... I'm probably going to go in like 20 minutes. So what should I spend the remainder of my time doing? Should we convert the input expression? It's infix to postfix. Yeah, so this is infix and we're going to postfix. I should learn to juggle. I could. I don't know how to juggle. That might be what I spend my 20 minutes doing. Did you make a pull request, Alka, on the LED thing? 8-bit LED. Working on it. Cool. No worries. Take your time. Take a 2-minute break and then stay for an hour. No, I'm definitely exhausted. Like, I feel it. It's really hard to think straight. So I think what we'll do is we'll implement this algorithm before I go. I could probably do this in 20 minutes. So we take an expression that we're given, like this, and convert it to reverse Polish notation. That's what we're going to do. And this is a fun little coding challenge. So and really I guess we can tokenize it first, because then we can just look at each individual token, and that's either output or operator. The recursive descent solution is about 10 lines. Is that the one that converts infix to directly to an abstract syntax tree? Is that what you mean? But Ashwin just asked, what sort of pull requests are welcome on the LED project? I mean, any. One thing that Alco was going to work on was allow a command that does animations. So instead of just sending one set of bits, you can send a series of bits and it will animate that. The one with one function per grammar rule / precedence level. Oh. We're going to do reverse Polish notation. Okay. So let's do that here. So it converts an expression to postfix. An RFC, like a request for comments? Is that what you're saying? Oh, okay. Yeah, no worries. Feel free. Oh, that's pretty cool. We could do bit shifting. Yeah. And in this case, cool. Yeah. So we're gonna do shunting yard. So this will be multiplication. This is division, and let's just do like multiplication here. Though, what's the expected output? I need some examples. Actually, let's just do a simple one. Like 3 plus 4 should return, should convert expression to RPN. Let's say that. So let's say RPN equals compiler dot tokens to RPN with the tokens, and we should expect that RPN to equal an array with 3, 4, and plus, like that. Yeah, and then we'll do another example like this. And this should equal that. Cool. So both of these are broken, but we need to create this function tokens to RPN. All right. We can do this. Here's the algorithm. So while there are tokens to be read to, so we really just need a for loop. I equals 0 all the way to tokens.length. I mean, do we need a while loop? I don't think so, but we'll see. Okay. If the token is a number, then put it to the output queue. So we need an output queue. Like that. And we also need an operator stack. And so a queue is first in, first out. It's like waiting in the queue at the movie theater. The first person in line is going to be the first person to get their ticket. Whereas a stack is first in, last out. So you stack things on top of each other, and the first thing that came in can't leave until all the things above it. So this is going to behave as a queue, and this is going to behave as a stack. In JavaScript, they have array methods, so we can treat them differently and use different array methods. Okay, so if the token is a number, then push it into the output queue. So it goes to the back of the line. first FIFO versus LIFO. Yeah. So we can use our handy dandy thing that we figured out earlier. So if that token is not NaN, that means we found a number. So we're going to do that right here. So if it's not NaN, then that means we have a number. And so we will push it to the output queue. So we'll say output queue dot push token. So that's going to put it at the end of the queue. Right? Yeah. Good. Very good. If the token is a function, then push it into the operator stack. What does it mean to be a function? Is that parentheses? If the token is an operator, then while there is a function at the top of the operator stack. Wait, what? Oh, like a Knight Rider animation, or like Kit, like his car when it's talking. That'd be cool. Oh, sine or cosine? Okay, yeah, we don't even care about that. We don't even have to worry about that. So, if it's an operator, it's not. Let's just look at this simple example. So 3, add it to the output, push the token to the stack. So if it's a number, we'll do that. Else, if token is equal to open parenthesis. No, the special case is if it's a closing parenthesis, because then we need to do something special. Else, we just take that token and put it at the beginning of the, well, push it into the stack. So we can say operator stack dot unshift inserts new elements at the start of an array. So we're going to unshift the token. So we're going to be putting it at the beginning of the array. The pseudocode was good if I just skipped the function bit. But I don't like this. While or. It should be fine. It's going to be fine. So we, okay. We're just pushing the operator in. But we need to check and see if the current operator has precedence over the operator that's already in there, right? X has higher precedence than plus. So it just gets pushed into the stack. 2 gets added to the output. Then we come across the division sign. Because division and multiplication have the same precedence, then we pop off. That's what the while loop was? Okay, while there is a function at the top of the operator stack, or there is an operator at the top of the operator stack with greater precedence. Okay. So we really just need like precedence rules. So if it's a closing parenthesis, we'll handle that later. But if it's an operator, we need to check to see if it has a higher precedence. So if operator stack dot length, there's something in it. So we're going to say top operator is the operator stack dot shift. So shift is going to take the first element from the array and return it. So we're gonna like basically take this off. We're gonna say does if top operator has a greater precedence than the operator that we just found. Did you break it? I don't think you broke it. Let me see what happened, because I'm validating that everything's a 0 or a 1. Nan. What? I'm not? I thought I was. Maybe I did it wrong. Doesn't matter. I'm working on other things. There you go. Thank you, Yuvraj. Add token to the output. Okay. X has higher precedence than plus. So if it has a higher precedence, then it can go into the stack. If they have the same precedence, you pop it off the stack. But I still thought I was validating every single digit after that. I don't know. I don't know. Oh, I see. I should no longer skip the first two. Yeah. Yeah, everybody's breaking it now. I shouldn't split it though. Okay, this is confusing me, but why? Well, there is an operator at the top of the stack with greater precedence. Pop operators from the operator. Okay, so we need to look at the top operator compared to this operator. And we could have like our precedence rules. Thank you, Doc. That's what I needed. I'm in a little mushy brained right now. Okay. I wonder if the program crashed. Let's see really quick. No, that works. Okay, so we grab the top operator. So if top operator, in our two examples that we're running this with, oh, in the most basic example, don't even need to do. Let's handle the most basic example really quick. Else we can just say operator stack dot shift token. Okay, simplest form. We're just putting it at the beginning of the operator stack, and then here we're gonna say while operator stack. Let's see though. Basically, we need to take the operator stack and put it into the output. Oh, we can just concat it. Yeah, we'll just concat it because it's in the same order. So we can say return output queue dot concat operator stack. This should work for the simplest case, this one. Though it doesn't. Why not? The concat is to take the operators and put them on the end of the output. Here. Oh, I didn't want to shift. Oh, sorry, I wanted to unshift. That's why it's broken. Because I want to put the operator at the beginning of the operator stack. Yeah, so... Oh. Well, now that one works. How? Yeah, that's what we're doing. So, this is we've been on a long journey here tonight at the Coding Garden, but that's what we've come to. We are now doing infix to postfix conversion. Yeah, so that first RPN one is passing. Now we need to handle parentheses. Just put it onto the stack. Okay, so we are here. So put the token onto the stack, but later on we only want to do this in certain scenarios. Say if the top operator, we'll say, has precedence. Precedence. Top operator and the current token. Oops. So if it has precedence, then we'll say the, we'll put it into the output queue. The top operator. What I saw here though was my stack. Basically, I'm treating this as an array, and I'm putting I'm unshifting them so the operations become at the beginning. And so now I have an array that is in this order, and I'm just taking that and then tacking it onto the end of the output. That's my thought, anyways. The top operator is operator stack dot length -1. Oh, well then I need to do a pop, not a unshift. Pop. So array pop takes it off of the end. Cool. So we have the top operator, and if the top operator has precedence over the current operator that we just looked at, or if they have the same precedence. I don't understand this. I'm not doing those katas. And hello, Ed. Hello, Katoli. What's up? Welcome. This is a 1Q. It's really hard. Yeah, no. So I'm using the opposite to make it behave like a stack or a queue accordingly. Okay. X has higher precedence than plus. So we shift it. So if the top operator... Oh, no. Okay, so if the top operator has precedence over the current one, so in this case, the top operator would have been like division. Or if they have the same precedence. Then it goes to the output. Let's do this. If same precedence, then it goes to the output queue. And then the token gets put at the beginning of the operator stack. And then we can handle this logic here. We'll say like if token is equal to a closing parenthesis, we'll do some stuff, else we just do this. And really all of this can be at the top level. Because if it's a closing parenthesis, then that's when we need the while loop to get rid of things. Yeah, I'm making this way harder than it should be. But let's write this same precedence function. What if we just take in an array of arguments? No. We need. So if operator 1 equals multiplication and operator 2 equals division, then it returns true. Or the opposite. And we only have to handle multiplication, division, and subtraction and addition, right? Precedence list. So multiplication, division, addition, subtraction. Why not use a regular expression? Because I'm tired. I'm really tired. And hello, Avi. How's it going? Okay, so if they have the same precedence, then we just take that operator and put it into the output queue. But if it has a higher precedence, it just needs to be pushed into the if higher precedence then we just put it in. Yeah, so if it has a higher precedence, we just put it into the operator stack. So, if operator 1 equals multiplication so if operator 1 is multiplication or division, and then operator 2 is addition or subtraction, then operator 1 has precedence. And see you later, Ed. Thanks for dropping by. So if it has the same precedence, pop it off. If it has a higher precedence, put it on. And then if it's a parenthesis, And hello again, Katoli. So if we found, and then we need to handle this one case. So if we found a closing parenthesis, we're going to pop off of the stack and push onto the output until we reach a closing parenthesis. And Andrew is thinking of streaming tomorrow. Cool. I'm going to be streaming on Rabbitworks stream. We're going to pair tomorrow. Take a quick stretch. We'll finish this while loop, and then I'll be done coding for today. And this might be the worst Code Kata stream yet. We've been live for almost 4 hours, and we've really gotten not very far. Okay. Can I repeat what kata I'm doing? Yeah, I'll share it real quick. Doing this tiny 3-pass compiler. We went down the path of actually like parsing things into abstract syntax trees, but now I mean I didn't think about operator precedence. So what we're doing now is we're gonna mostly scrap that code and first convert the thing into reverse Polish notation, which will handle operator precedence for us. And then once we have that, we can parse it into an abstract syntax tree. Oh, wow. Okay. Yeah, it reminds me though, I got a mess. Oh my goodness. Out of memory? What? How? Uh, I have an infinite loop somewhere. That's okay. We'll fix it. Ah! Yeah, my fan is spinning up. Good morning, GameStep. Welcome. If token equals closing parenthesis, operator stack.pop, push it into the output queue. Because by pushing it, yeah, it's gonna show up at the end. And we would then pop off, and once we get an opening parenthesis here, it'll stop looping. Let's debug. Well, debug this really quick. This one should just work though, I thought. Okay. We've got our queue. We've got our stack. And our tokens are 3 plus 4. Okay. First token is 3. So we should just push that into the output stack. Done. Next token is a plus. So our top operator is actually undefined. That's what we need to handle. So if there was no operator in the stack, we actually just push it in. I definitely need to handle that. We are literally running out of memory. I'm curious why we don't see like an infinite loop or something like that. We're literally doing something that's just growing the memory forever. Um, oh, we can look at these output reports too. Well, now. Allocation failed. Cool. All right. Does anyone know the algorithm to calculate an RPi expression? What is RPi? But yeah, let's debug this one. Okay, so we have the value 3, we push it. We now have a plus sign. So there is no top operator. So we should push that token plus into the operator stack. Cool. Our next token is 4, so we should just push that to the output queue. And then we have no more tokens. So the return value is 3, 4, and then plus. So this one should pass. Why is this failing? Let's debug this one. Oh, RPN. So yeah, I'll link you to this. It's the shunting yard algorithm. Doc introduced me to it. So that's what we're trying to implement right now. And it's taking me a lot longer than it should because I can't think straight and I'm tired. And hello, Mahidra. Welcome. Welcome to the show. Okay, so we're debugging it. Wait, what? I mean, our higher precedence and same precedence might just be wrong. Oh, don't know what to do with that? I mean, ultimately, calculating it is very simple because you pop numbers off, and then if you pop off an expression, you execute that against the last 2 numbers that were popped off, and it just takes care of precedence for you. Okay, let's try this one more time. I want to debug this. Why is everything breaking? Why am I running out of memory? All right, I have my tokens. The first token is just going to be, wait, 3 plus 4. Oh, no. I want to do the next one. Okay, here. The first token is, and our tokens are this, yes. The first token should be 3. Push it in. Next, the token is plus. So there is no top operator, so we just push that into the output stack. The token is plus, yep. Back around. Now our output stack, or operator stack has plus. Our output queue has 3. We then have 4. We'll just push that in. We then have, what's the next token? A multiplication sign. Let's see what happens. So if plus has a higher precedence than multiplication. It's just shunting yard. That's what I'm trying to implement. I don't want to get the solution. I want to solve it. But why is this happening? Wait. What's the example up here? 3 plus 4 plus 2 minus 1. Yeah, I mean, there is this pseudocode, but it confused me because they were talking about functions. Okay, if the token is a number, put it in the output queue. Done. If the token's a function, don't got to worry about that. If the token is an operator, then. And thanks for the follow, Utori. There's a function at the top of the operator. While there is a function at the top of the operator stack, or there is an operator at the top of the operator stack with a greater precedence. Or the operator at the top of the operator stack has equal precedence and the token is left associative. And the operator... This is too much. If the token is a left parenthesis, then push it onto the operator stack. We're not handling that case. I really don't understand how we can run out of memory. Like what are we I'm not doing anything that would result like in an infinite loop. Skip that part and left-right associativeness. Oh, I need to do something with the top operator because I'm popping it off. There are just two cases, plus and minus, in which case you look for all operators. And if it's division, or you only look for division. Download more memory. Yeah, download more RAM. The thing is, I've done an RPN calculator before. Oh, no, this is not RPN calculation. This is parsing. This is a different problem. This is the shunting yard algorithm. See you later, Kitoli. Have a good day at school. If the top operator has a high... Wait, what? I just need to find a different pseudocode algorithm for shunting yard. Brilliant.org. The stream is not brought to you by Brilliant.org. Let's see. One stack for operations, one queue for the output, one array or other list of tokens. Okay. This is easier for me to understand, at least at first glance. The case I was missing was brackets. I'm handling parentheses here, but let's just do this. If it's a number, I am very tired. It's almost midnight here. I gotta go to bed, but I want to at least finish this before I go. If it's a number, add it to the queue. Done. If it's an operator, And really, I should just have an object of operators. Addition, subtraction, multiplication, and division. Okay, so we'll do that right here. Else if token in operators, if it's an operator, while there's an operator on the top of the stack with the higher precedence. So that's what I was doing here. Oh no, I need to do a while loop. Okay. So while there's an operator on top of the stack with greater precedence. So while greater I'm losing an element, but I'm taking that element and putting it into the output queue. While there's an operator on the top of the stack with a higher precedence. Pop operators from the stack onto the output queue. Push the current operator onto the stack. So we could just do operator stack dot shift unshift token. So back to the pseudocode. While there's an operator on top of the stack with greater precedence, pop the operators from the stack onto the output queue. So that's what we're doing. And then push the current operator onto the stack. That's what we just did. If it's a left bracket, push it onto the stack. Else if token is equal to a left bracket, operator stack dot unshift the token. If it's a right bracket, okay, so this is the final code, and actually we don't need to do that anymore. If it's a right bracket, while there's not a left bracket at the top of the stack, pop operators from the stack to the output queue, pop the left bracket from the stack and discard it. That should do it. That's the winner. Cool. So this gave us 3, 4, I'm missing 2, 1. While operator stack dot length and operator stack. Oh, I'm losing them because of the pop. I see. I see what you're saying. So the top operator is just the last one. So while and then I do the pop. So if that top operator has a higher precedence than the token, pop it off, push it in. Interesting. Same thing here. Oh. Higher or equal, and it's not parentheses. Higher or equal. So, equal precedence? Okay. Same precedence of operator 1 and operator 2, and higher precedence with operator 1 and operator 2. That's an or? Or. So the top operator is equal to no, not the length. It's the first one. The top, it's 0 because I'm treating it like a queue. So it's sorry, like a stack. So it's 0. So the top operator is going to be at 0, and we're just storing that in a variable. And then yeah, I see. Because that way, this will just use it, and then we can evaluate this right here. No. I want it to be at 0. Okay, so we're really close, except... Though, actually, let me log the output that we're getting. No, not here. Test. Why does this have a check mark next to it? Pop takes from the end. Oh. Yeah, then I need to use shift. Wait, what? Yes. And then operator stack, we're using shift and unshift, because unshift will put it at the beginning. Yeah, that's the one. And thanks for the follow, Super Hoobie. It's two different things, because the output queue is a queue. So for that, I'm using push and pop, because in JavaScript, push will put it at the end, and pop will remove the last one. We're never popping off of the output queue. So we're always pushing to the end of the output queue. Because it's a queue. And then the operator stack, we're always putting things at the beginning. So whenever we add something, we're doing unshift, which puts it at the beginning of the operator stack. But whenever we want to remove something, we take it from the beginning, which is a shift. So I think I've at least gotten that right. If I only pop for the higher precedence, the end result is the same. Okay. It passed? This one's failing, though. Let's get rid of this test. Something's seriously wrong with the Jest runner. See, it's saying this one is passing, but I don't think it is. Let's look at it. So 3 plus 4. That's going to give us back 3, 4, and then our operator stack has plus in it. Yeah, so this one should pass. Well, there's that. The output queue has 3, 4, 1. And we're going to concat. Yeah, there for some reason there's a parenthesis on there. Operator stack.length and operator stack at 0 does not equal that to the while loop. Which while loop? There's multiple while loops. Let's make sure there actually are operators. Yep. Oh yeah, because operator stack at 0 could be absolutely nothing. And in that case, we just put the token on. What just happened? I'm at a point where I cannot read the the test results. So we're gonna result to just console logs. No, not that. And it's saying that that one's failing. So we're getting back 3, 4, 1. Where'd the 2 go? Two equal? What about it? Where I have that lone operator stack.shift, you need if operator stack at 0 equals parentheses. Here? If it's a parentheses, shift it. But if we found a closing, we would have found an opening? Excuse me. I really don't understand why Jest is saying this one passed. So we're missing the 2 and we're missing the minus sign. Okay. Is 2 equal a thing? I thought that were the errors coming from. Oh no, yeah, it is a thing. It's how you do expectations in Jest. It's different from chai, which is like .2 .equal. Okay. Now we're gonna look at the tests. All right, that's what I like to see. This is the broken one, and this is the one that needs to be fixed. So let's try to debug it. Three plus 4. We know that that one works. Now these are our tokens. All right, so we're gonna go all the way until we get to that opening bracket. So at this point, our output queue is 3 and 4. And our input was 3 plus 4 times. Okay, so our output queue is 3 and 4. Our operator stack is multiplication and plus. Now we have just reached a open parenthesis. And tokens. Oh. Our tokenizer is wrong. It's showing this as 2 minus. I didn't write the tokenizer. I did not write the tokenizer. Oh, man. Let's just look at the tokens really quick. Yeah, why is it doing that? Yeah, did ESLint fix one of the regular expressions? Let's see. We'll just copy and paste it exactly as it is. This just isn't valid. It's not a valid parser. Well, I guess the input, we're never going to receive an input that looks like that, ultimately. So what I do care about is, I guess, just like parsing something like this. Just stop using ESLint. Oh man. Okay, I think that whole time that's what we were up against. It's just like parsing the wrong thing. Our tokenizer is broken. Let's pass it in manually and see what happens. So if we literally pass it an array with, 3 plus 4 multiplication, open parentheses, 2 subtraction, 1 close parenthesis. But how is it broken? I don't know. I have no idea. Wait, yours, are you saying yours isn't broken? What? Is it telling me that my minus sign is not a minus sign? uh... It's a suspicious minus sign. Okay. Maybe that's it. It's because of the copy pasted minus sign, which makes it weird. Yep, that's it. That's what it is. That's why the tokenizer is broken. Because I copy and pasted this expression, so I'll do that with the tokens. Is it an n dash? It might be. Yep, that was it. That was it, everybody. We can all go home now. So that I copy and pasted that from the Wikipedia article, which is this. Yeah, let's figure out what chart code that is and compare it. Came just back just in time to solve it. Yeah, that's 8722, which is not the same thing as this. It's a fake a fake minus sign. Chart code at, yeah, so 45. 8722. It's my own fault. I should have typed it manually. But that's working. Can someone give me a more complex solution to turn into RPN? And actually, we need our RPN to handle arguments as well, because like in the case of this, we actually need it to not mess up with X, Y, and Z. Those aren't operators. So really, we could say, instead of saying if it's not nan, we can say if it's not in the operators and it's not a parenthesis. Like that. Cool. So now it should be able to handle if I pass in something like this. Yeah. A lot. 2 plus 2 is 4 minus 1. That's 3 quick maths. Do we know what this is in reverse Polish notation? Yeah, definitely rip Kobe. I heard about that. I was streaming the other day, and people in the chat were mentioning it. So 2, 3x times 5y times plus 3z times minus 1, 3, 2, 2. Is there an online infix to postfix converter that we can use? All right, let's try this one. Two, 3, 9, 3 minus multiply plus 67 times 3 plus divided 62 plus. We got that one right. Do we know what this is in RPN, Marcus? Algebraic and what is happening? It's too much. Good morning, Julian. I think this is a 1Q. We're actually doing, yeah, tiny 3-pass compiler. And we're nowhere near finishing. I'm gonna go now because I've been streaming for over 4 hours. All right, let's try it, Marcus. And what we're doing right now though is because we went down a path. I started creating like subtrees for the abstract syntax tree, but what I realized is I wasn't taking into account precedence. So what we're doing now is converting the equation to postfix, so that way creating the abstract syntax tree will already be in the right order. It's the plan. But that's for next time. ABC times DE times F plus G times plus plus. Oh, wow. Yeah, and for anybody else watching, Julian is like the master of Code Wars. If you look on our Coding Garden clan, he's all the way at the top. Look at him. 14,000 honor. Almost 15,000. I have a measly 1,600. Yeah. Okay, so, everyone, we spent a good 30 minutes debugging that Unicode issue. Yep. So the clan is literally coding space garden. Like that. I'm so tired. I gotta go to bed. Alka's at 589. There's a lot of people in the Coding Garden clan. That's pretty awesome. Cool. Okay, we didn't finish it. We didn't really even come close, but we did write quite a few tests. I think on your profile you can just set your clan. Like if you go to account settings and then type your clan name. But yeah. Cool. So we didn't get very far on this, but I'll finish it next week. I kind of don't want to. Kind of tired of it at this point, but next week I think we'll revisit it and try to finish this one up. There you go. Go to users, edit, and set to Coding Garden. Cool. But we got a infix to postfix conversion working. I've never done that before. I've created an RPN calculator, but I've never converted infix to postfix. So here we are. We accomplished some things tonight. We also wrote quite a few tests, which is cool. And I will say, It's not a complete loss because this abstract syntax tree parsing code we wrote can parse things like this, but it just can't handle precedence or order of operations, which is why we had to go back to the drawing board. It is a week away, yeah. But I'll mention it again. If you tune in tomorrow, I'll post it on Discord, and I'll definitely post it on the community tab. But tomorrow, I am going to be calling in to Rabbitworks stream. So I'm going to help him debug a cores issue, and I'm also going to do a code review. So he's been working on this full stack auth from scratch application. So we're just going to pair a little bit, so that's going to be pretty fun. So you can check that out tomorrow night at 19:30 GMT minus 7. But I'll be live on his stream, so that'll be fun. And I'll be sure to post the links on the Discords and all that other good stuff too. You got 2 plus at the end, while in my postfix, one of the plus came in between the expression itself. That's what I meant by having the same result irrespective of equal or higher precedence. Oh. We'll fix that next time. Because it might be broken, but we'll fix it next time. Cool. I'm tired. I did this way too long. Though, shout out to this website, which I'm not going to say out loud, which gave us the good pseudocode. It's time to go, guys. Let's find somebody to raid. If anybody is live. Who's live at midnight on a Wednesday night? Oh, Codephobia is. That's who's live right now. Yeah. Thank you, Doc. Doc's been with us the whole time. And I can't believe it because I was definitely ignoring him at the beginning of the stream. When I shouldn't have. I should have listened. Hello, Evolve Your Mind. You have made it to the coding garden. We do lots of fun things here. We like to code. We have this nice fun drop game. We have an LED command so you can set the LEDs, but I'm ending the stream now, so we're finding somebody to raid. But if you tune in every Wednesday earlier than this, you can watch me solve coding problems. Coding cool features for the Elgato. That sounds like fun. I guess did Codephobia go offline? Sorry, there's only streaking as a service. What? What code is this? Full screen. C++. So that's cool. How to code well. Adding HTML forms to Gatsby.
It's good. It's not just.
What a Twitch name. How to code well. Codephobia is chill. Where should we go? Let me know in the chat. First 5 people to answer. Should we go to Codephobia or How to Code Well? Let me know. And if you're watching on YouTube, head over to twitch.tv/codinggarden. We're going to do a good old-fashioned raid. Hello, Sean. Hello. Yeah, everyone says Codephobia. We'll do Codephobia. How to code well. How to code well. I think the Codephobia is habit. So that's what we'll do. Let's get that raid message ready. If anyone could please put the raid message in the chat. Yeah, it's a good name. It's not how to code good. It's how to code well. I'm tired. I'm so tired. All right, here's the raid message. Yeah, there we go. Alka's got it. Copy and paste that. Nice. Thank you, Terminal Bash. I'm gonna get some good sleep for sure. For some reason, I thought tomorrow was Friday, but it's not. It's Thursday. So, yeah, that's a thing. Alrighty, everyone, wherever you are in the world, have a wonderful morning, afternoon, evening, or night. Excuse me. And until next time, here's this.